Everybody, welcome to the stream. It's been a little bit, hasn't it? The longest it's been since I started streaming, at least. Let's get right into it. None of the faff. We got active Discord. Let's make our little announcement. Whoops. There's 2 slashes. Suraid says, "Yep. What's up, Suraid? How's it going?" The first one in. Compiler part 36. Getting back into things. Notice. Hey, look. Oh, nope. Notice. I was about to say, hey, look, I got it right. And then I didn't get it right. It's a classic. I threw together a solver for it using DFS. What is DFS? It's probably some fancy thing. We have to check it out. Here, one sec. Okay. Sorry, had to throw you to Emacs for a second. I still don't know what DFS is. I gotta know. How's it going, Suraid? Thank you so much for tuning in. I very much appreciate it. What is DFS? Backtracking. This is gonna kill me. Depth first search. That's what it is. I remember now. It's gotta be depth first search. Backtracking helped me out. Yeah. Yeah. Hey, RPWH says, yeehaw! We were just looking at your Hexadoku solver, since you shared it in the Discord. Suraid says, been taking a break from programming for a day or 2 after opening that second PR. Lamau, you have done so much code. RPWH says, that's me. That's Rory. Oh, RPWH. Oh, that's you. And now that's not you. Back in the Emacs. Oh, so mean. So harsh. I'm sorry, RPWH. We still love you, even though we can't see you anymore. Suraid says, been taking a break from programming. How has that been for you? Has it been pleasant? I've taken a forced break from programming for the past like 10 days. I haven't really programmed much. I've had to do other things. And yeah, that's how it's went. Yeah. So we are gonna have to do something, because I did make a test one day. I had like an hour and I could code. So let's figure out how I can get back to the main branch. That's the idea, that they'll be overwritten. Okay, so we're just gonna stash everything and say, this was a test.jpg. That's the name of the stash. Okay, now can I switch branches, please? Hey, we did it. Okay, so where are we at now? Oh boy. RPWH says, hopefully you've come to the end of your stresses. Oh, thank you, RPWH. You're so sweet. You're the best. Suraid says, also, you might want to look at the second PR first, maybe, because that summarizes everything. That's a good point. I don't even know. I don't remember. I have the memory of a goldfish. I have to remember what we were doing. So I gotta look at some stuff. Let's look at our most recent commits. What did I do last? What did I screw up most recently? Okay, so we had developers.txt. That's right. We had like the PDF and describing everything. And I'm sure now it's horribly wrong. Because I have had a little bit of free time in the past 10 days. And I've learned a lot. So I think we're just gonna... we're gonna yeet a lot of developers.txt. I should be saying tech as well. I just read the X like a dummy. Suraid says the first PR is the IR branch plus register allocator, and the second PR is a detailed explanation of the register allocation process. Ooh. In developers.tech, that is. Yeah. So intermediate representation plus register allocation. That's a lot. That's a lot to go over. Okay. What if we're just gonna do it from scratch? If we ever get lost, we'll use your PR as a guide. And the idea is we'll end up with a code base that is identical to yours, or at least functions identically. How does that work? Then everyone gets to see how it's built, and I get to remember everything along the way. I don't have to remember everything at once all today, because I don't have 6 hours, sadly. I'm trying to prioritize. But in these 2 hours, I could probably get like the beginnings of an intermediate representation. We're just going to go for it. So the idea is we're just going to start coding. We're going for it. And it may be smart to make a new branch, but I've never been smart in the past, so I'm going to regret this so much. It doesn't matter. I just have to figure out what the hell's going on. Okay, so currently we have code gen. And to me, this code generation is literally code generation, I'm pretty sure. Like each one of these emits to a file. Like, yeah, we're literally fprintfing into the code file as we emit. So when we talk about codegen.c in our current state, Sir Aid says the second PR explains mostly just the register allocation process. Also, I use Ascii latex, so I'm not entirely sure if it compiles with PDF latex. It should be fine. It should be fine. Okay. Okay. We can try it. Let's just try it. I have so many old tests. I gotta get rid of them. Okay, so we're gonna git clone. Do you remember your URL? No, I got it. Let's see. GitHub. Oh, Christ. Fun compiler. That would be the one. I'll bring you guys with me on this. We're gonna try and clone some stuff. I don't think it matters. I'm gonna have to switch branch once I clone it. Hey. Okay, clone into, oh god, we're gonna call this docs. Oh, did I already clone this? Docs PR. I probably already cloned this when I had a time one day and then didn't do anything with it. Lamau. We're gonna call this docs PR reloaded in true Sir Aid fashion. That's pretty amazing. It was right there the whole time, chat. Yeah, look, I did that yesterday. Okay, where are we at? Docs. Okay, then I can close all this craziness. And we can open. Oh yeah. Oh yeah. Like the Kool-Aid man. And we're just gonna go for it. It looks good. Shoddy shot. Oh, I screwed that one up. My bad. There it is. You're on the wrong branch again. Lamau. Thank you. I never remember. Control X G for maggot. Interactive. I think I just go branch. Local branch. What? Am I in the wrong spot? I'm in the wrong spot. Okay. We're almost there. I'm just gonna go into developers.txt. That'll help us. Ooh. Oh, I thought Emacs crashed, but we're good. I was like, uh-oh, it's not looking good. We're gonna want to run this, but we don't need to because we need to switch branch first. Again, I have a goldfish memory, I'm sorry. So we go branch, local branch. There we go. We can go to the docs branch. Give me that. Perfect. Hey, look, it's all different. Now we can rerun our LaTeX thingamajig, PDF tech, and yep, still worked. That's a good sign. And PDF. I don't want to look at funguage. We're gonna go with yttrium. I just can't look at funguage. It bothered me. I don't know why. Okay, yttrium. Also, you didn't add your name to the authors list. Oh man. Sir Aid, it's basically just chapter 5. Just chapter 5. Pages 14 through 25. Also, why'd you mess with the chapter spacing? Oh, why? Why are chapters so far down? Weren't they up here? I'm pretty sure I had it in there, but they were up at the top. This is horrible. Oh no. The chapter formatting is a bit off right now. Well, this is like default. This is what it's like by... It's a little bit up still. I just had to enable chapter and section numbers. Yeah, I'm gonna disable them, because not having them is a travesty. It's not true. There's no need for numbers. If you want to number them yourself. Why does there need to be numbers? They have names, specific names. If you want to do enumeration, you can just count. It's not too difficult. There's so many good reasons to have chapter and section numbers. Nick 1666 says, "Is this a LaTeX doc?" This is a LaTeX doc. This is the source right here, which we're on Sir Aid's docs branch. We're checking it out. I'm angry at him for undoing formatting that I chose very specifically. Sir Aid says, "Source, I have typeset multiple books and papers. This isn't a book or a paper." Nick says, "No way." Sir Aid says, "I always get lost when I have to proofread a paper that doesn't have section numbers." Daniel B, hello, hey guys, is what he says, the emoji. Yeah, well, you'll never have to proofread this paper, and if you do, you can add the section numbers yourself while you proofread it. But in the final document, we're not going to have section numbers. Chapter numbers, I'm not averse to. We can have chapter numbers. Because that's kind of how chapters work universally. It's not like chapter register allocation. That wouldn't make sense. Chapter 5, register allocation, makes more sense. But having phi elimination be 5.1, interference graph 5.2, adjacency matrix 5.2.1, that's so much. And it's, I don't know if it's needed. How are we going to do cross-references with hyperlinks? Why not? It doesn't matter. This isn't a printed out document. It's a digital document for developers of a programming language. You can't really do C section 5.4 if you don't know what section 5.4 is. Yeah, you just... didn't I do a cross-reference? Isn't there hyperref in here? Yeah, just use hyperref. It looks like you took it out. Just use hyperref. Link the doc, mayhaps? What do you mean link the doc? I don't know what that means. Sir Aid says that's jank though. What's jank? How's it jank to have a hyperreference with a unique label and a name? How's that different than a unique number and no name? Send a link to the document. Well, you have to build it yourself. That's how LaTeX works. So I don't mean to be condescending, but this is a LaTeX document here. So this is available on Sir Aid's branch of the compiler. So you can go to this here. You can clone it like we did. You can go to the check out the docs branch. And then after you've checked out the docs branch, you can build this with your thing of choice, your LaTeX distribution. That's what it is. I use Mictech which is for Windows. So it provides PDF LaTeX, but there's also Ascii LaTeX and a bunch of things. Boom. And then you just build it. It does a bunch of things. It may have to download some packages. It should all be okay, but do be wary. Code that you are downloading off the internet will be run. And then it generates a PDF that you can read. But yeah, Nick says, okay, thanks, I meant the source. Well, my bad. It's all good, mate. It's all good. It's always on the GitHub. It's always on the GitHub. Okay, where are we at? Chapter 5. So it looks like none of this has been changed, which is a travesty, because it's all very, very confusing, and probably the worst possible example for an introduction to code generation for a new developer. So let's not have that be the case, you know? We're just gonna yeet this whole chapter and rewrite it. I like this. This sucks. The names suck. Having it all is very confusing and unexplained, and it presumes a lot of knowledge, which I don't think everyone may have. So we're gonna try and have it be a way simpler introduction. The live ranges diagram is nice, I agree. That Emacs that Emacs Ascii art really comes out in my LaTeX documents. So it says, it also helps you distinguish sections from subsections. At least I can't tell if something is a section or subsection just by the font size. I see. We'll just format sections and subsections with different amounts of indentation. The headers, that is. So the name of the section would be indented more if it's a section. If it's a subsection, it could be indented way more. You know what I mean? Just have it in. So we'll keep literally just this diagram, all of chapter 4, yeeted, gone. It doesn't make any sense to start with that as an explanation. But it did help me learn, so there is that. Chapter 5, Register Allocation. So this is by Sir Aid. You can tell because it has fancy footnotes and stuff that I would never know how to do. And or care to. I would just put it in parentheses and call it good. Because I'm lazy. Sir Aid says, I love footnotes. Oh, I know. We can tell. When the first page of your chapter starts with a footnote, we can tell you love footnotes. There's not one on every page, so that's good. Right? There's 2 on this page. That's pretty good. 2 on this page. 4 on this page. You definitely love footnotes. This one doesn't make any sense. Looks broken. A lot of footnotes. These are amazing graphs, though. Beautiful. It's a little abstract, but it's okay. See if the lower left triangle matrix. Okay. I'm just trying to figure out large scale what it's about. The footnote that looks broken is literally broken across 2 pages. That's how footnotes are formatted when that happens. Where's the 10? Oh, so... Wait. So this one moves on to the next page down here. Oh, that's horrible. But there's so much space. It's so funny. It's like you should just move this down here. And move that down. Move that down. It's so obvious to a human, but I get why for computers it's hard to format this stuff. They're not as smart as humans, which is a good thing, I guess, for now. Okay. File elimination. So register allocation. What do we talk about? I'm gonna skim it. I'm sorry. I'm not gonna read it all. The interference graph. This is all good. It's a little technical. What does this mean? Yeah, I don't know what this means. I think this is too technical. V prime, VV prime. This is a much too technical explanation. That used to be a lot more common like 100 to 200 more years ago. I've seen books where the footnotes would routinely occupy more space on the page than the actual text. Lamau. V in V. For every vertex in the graph V, and V is the vertices, a set of vertices, I would presume. That's like elementary set graph theory. Well, way to talk down to me, Jesus. Do you forget that I am like 19 years old and very stupid? I didn't go to fancy universities. I just learned this stuff myself off of YouTube and Wikipedia. So the fact that I haven't seen this symbol just means that a teacher didn't sit me down and go, this symbol means this, right? And I've never seen it, so I've never looked it up until now, in which I saw it. Soraid says, to be fair, I did kind of assume a basic knowledge of graph theory for this, so maybe it is a bit too technical. Do you think? Do you think expecting a basic knowledge of graph theory may be a little much for a compiler developer? I think it's a little much. I don't think it's needed. And it should be explained if it is needed. It should be like a base level program where like a Python developer who just wrote like a program which asks you a word to input and then it like tells you hello, your name. You know what I mean? I want to go from there to compiler dev. Sir Aid. So explain everything is the idea. Sir Aid says, I see how it is. I had basic set theory in secondary school when I was like 15, so I kind of just assumed that most people would be at least somewhat familiar with it. I wasn't in school at 15. Eternal Wild Fox says, hello, how are you doing? I'm doing okay. I've had a rough 2 weeks, but you know, we're back at it. We're doing coding. But yeah, it is very complicated and a very technical explanation. I do get it now. So the process of coloring a graph consisting of a bunch of things like vertices, they could be nodes or vertices. In my head, the word node makes more sense, but vertice is probably what it's called in the mathematical sense. So assigning to each vertex V, which is within the vertices V, which is within the graph G. There's a lot of letters here. A color from 1 to K. Confusing. So a non-zero coloring. Okay, so a color from 1 to K. That has to do with what you're assigning to. Such that no vertex in V prime with VV prime in E. I don't know what. So E is edges. VV prime, I have no clue. That is no vertex V prime adjacent to V has the same color. I'm lost. Okay, so you're basically saying assign a color that's between 1 and K inclusive, such that no vertex, just A, it could be X, could be, you called it V prime, which is very confusing, but it's no vertex V prime. I don't know why that's a thing. Maybe it's talking about this V. Like, wouldn't it, for each vertex V in V, wouldn't you just talk about V here? Why is V prime? I'm so confused. VV and E means the edge between V and E, where E is the set of edges. So why do you have V and V prime? I'm so confused. So you're talking about a relationship between two nodes, between two vertices. So no vertex V in V. So V refers to every single node in the vertex. So this is literally like two loops on the same list of vertices. So it's saying for every vertex, this is so much. V could also just be called something else, and it should be. It should be a full name. Why is it a single letter? Maybe it's easier if it's a single letter, but I don't think it is in this case. I think we should just say vertex, or node, or item, or iterator. Something that like a programmer would understand. Give it a variable name, right? Because if you gave a variable name V in code, I think you would be smited. Sorry, it says, I just like this naming convention a bit too much, lol. This is basically the formal definition of graph coloring. Exactly. RPWH says, so V, V prime, and E is just all edges? Yes, RPWH, you're a genius. Surade says, it's mostly just for completeness sake. Also, that wasn't sarcastic, RPWH. I know I sounded a lot. I'm serious. Like, if you just understood that from what I just said, then you're very smart. Because I still don't understand parts of this. So, like, it's a little confusing. Neg Vorsa says, it's clear to me, no problem. I see. I'm just the dumb one. It's okay. Sarade says, no. I don't know what he's saying no to. Eternal Wild Fox says, I've been busy, released BuildMake 0011, that's a lot of semantic versions, with support for C++ and C# projects in Visual Studio 2015-2022. Oh, through 2015 through 2022. Wow, that's a lot of support. I would love to see support for an open source compiler for C++. That would be amazing. Eternal Wild Fox says, also, I'm working on a C# library for OpenGL, Vulkan, and DirectX. How do you do so much? Like, you've been supporting Visual Studio, one of the hardest compilers and IDEs to support, as a build system generator. And then you're like, oh yeah, also I'm doing 3D graphics in OpenGL, Vulkan, and DirectX, which is like all of them. That's hilarious. Neg Vorsa says, it's clear to me, no problem, I already read that. Sorry, it says V is any one vertex in V. So any edge in E. But yeah, this just means any edge in E, right? This just means for all edges. Basically, for all edges where V is included, they can't have the same color. No vertex with VV and E means no vertex V such that there's an edge between V prime and V prime. What? Any edge between some vertex and V, yeah. That's so confusing. So V... these are horrible names. V is both referring to a singular vertex and also any vertex within V. Sorade says, I'm using single quotes, which means prime is how we were taught it in like elementary school. In like 6th or 7th grade, we got taught that like a tick after an algebraic variable, like if you say x with a single quote after it, that's x prime is how it's pronounced. I don't know if that's correct. That's what I was taught in school. So it's this I've been reading as V prime and V prime. So V prime is a separate thing from V, but it relates to it, but I don't know why it's used. Why wouldn't you just say V and like X and Y or A and B, right? It gets so confusing with this naming. Like, what? This is like in programming, naming your variables V1, V2, V3, V4, and going, no, it's readable. Yeah, it's pronounced prime. I'm saying I use single quotes, and it can be a bit confusing when I single quote text that contains V. Yeah, I don't know when that would ever happen. But I get it. It would be very confusing. Or to put it differently, the process of assigning at most k registers to the temporaries that make up a function consists in so to the temporaries that make up a function, if it ended there, it would make sense. The process consists in assigning, is that supposed to be consists of, assigning to each temporary a register between 1 and k, such that no temporary that interferes with it is assigned the same register. It's impressive you wrote this, by the way. You have to have a deep understanding to write like this, because I can't. This is very technical. Sorage says that should be consists of. Rip. Lamau. It's all good. That makes sense now. I proofread this, but I must have missed that. Rip. You're never expected to be perfect. It's okay. Nick1666 says, while prime is correct for cubing notation at least, for instance, R's rotate the right aside, counter CW? What is it? Clockwise, that's what it is. But R prime is counterclockwise. Nice. Nick says clockwise, thank you. My goldfish memory is coming out some more. So it's taken us about 5 minutes to read these 2 paragraphs. I think they're a little too technical. Lamau. It's like a Wikipedia page. It reads like one. It's a little tough. It's like you gotta read it 8 times and go, I guess that makes sense. I understand it now. It's okay. I'm just dumber than most. Perhaps that should be a footnote instead. I don't know. I don't think a footnote makes anything better here. It's not formatting. It's just the text. It's a little verbose. What are temporaries? Like, I know they should probably be explained up above, but the temporaries that make up a function, what does that mean? Wouldn't it be a program? Aren't we have to, register allocation works on, we're doing global register allocation, which means we work on the whole program. We're not working on just functions. Otherwise, we would have to very much, we'd have to very much do a lot of saving and pushing, because we're going to do intra-function call boundaries. No, this RA operates on a per function basis. Well, I see what you're saying, but when you're done with register allocation, all of the functions in the program have had registers allocated to them, is my point. So it's like, it's not just for one function. You take the whole program and assign each temporary in the program a register between 1 and k. But I understand that it interferes with no like in-use registers at the same time, and that's kind of harder to say, because that's when the bounds of being within the function come into play. I understand the difficulty. It's just it's a little confusing. Like, so we can only allocate registers to a function, because we already say like we do things for the whole program, but we do them function by function. The functions are processed one at a time and independently of one another. That's why I mean with the temporaries that make up a function. That's fair. The whole thing about functions in this chapter is a bit jank. So how are we going to deal with like caller saved registers if you don't do function call boundaries? It's going to be a little rough. I just couldn't think of a better way of phrasing this. There's probably not one, to be fair. And if there is, it probably takes longer than it is worth to come up with. Unfortunately, graph coloring and by extension register allocation cannot be solved in polynomial. Yeah, it's NP complete. Following sections are only a high-level overview of RA. Both the actual implementation and theory behind it are rather complex, and writing an RA that can account for every last quirk. So if we say register allocator, we should probably abbreviate it everywhere. That can account for every last quirk that an architecture may have, and which can correctly allocate registers for any well-formed IR program. It's a fairly complicated endeavor, and our current register allocator is still a far cry from that. We don't have to abbreviate it everywhere if you think it makes more sense or there's emphasis added. There's reasoning, go for it. I'm just saying if there's no reasoning, probably should keep it consistent. Nevertheless, in what follows, we present a hopefully not too complicated description of the general RA process as well as the theory and ideas behind it, the reason as to why certain things. Sorade says, well, right now caller saved registers are just pushed and popped, but copy elision and coalescing should hopefully be able to get rid of most of that. Right now I just wanted to finally have something that works. That's fair. I gotta look at it. I have too much curiosity. I gotta look at it. Are we on the right one? No. IR? Codegen? Okay. How's the back end work? That's all I need to know. IR call. How do we make an IR call? What's it called? Probably in all caps. Call. Skip. Okay, there's I call. Something to look for. Perfect. So where do we create one of these? We never create. We never switch on one of these or create one. It's amazing. So it's got to be a IR instruction. These look like types. Yep, switch on value type. IR instruction call, emit call. Hey. Is that a GNU assembler intrinsic? Is that like a built-in into the GNU assembler? I'm confused. What is __call? Not the Dunder method. Hacking with PHP. No. Sir Aid. Save caller, saved registers in a middle call instruction. This is a horrible hack. Yeah. When I read what you just said. No. This should only need to emit a call instruction once we have an RA that handles caller saved registers. This only works with gas because it involves gas macros. You used macros in the assembly we're outputting? Sir Aid, your addiction has gone too far. Oh no. Not Yes John says, I'm about to head to bed, but I'd just like to remind that your code is sick and also cool. Fact. Chainsaws were originally used for childbirth. Nice. Gotta open them up. Not Yes John. Amazing to see you. Thanks for popping in as you always do. And keep it real. Thanks for tuning in. Sroid says, I mean, to be fair, I did call it a horrible hack. I know. You're correct, is what I'm telling you. Your addiction has gone too far to even consider assembly macros in compiler output. No. No. How'd you even come up with this, man? And the thing is, information on proper ROA is not that easy to come by. There's no information. That's why you can make it up. Not Yes John says, I hope you're having a great day and you're as sick as your code. Oh, Not Yes John, thank you so much. You're so awesome. I love you, Not Yes John. Thanks for tuning in so much. Sroid says, I was working mostly with a book from the 90s and doesn't even assume that the program is in SSA form. That's okay. You can. Nick says, the what? Why would you do that? I know. I don't know. It's a horrible hack, as mentioned. It's okay. And I don't want to dwell on it, but I can't. What is under. I gotta look at this now. I gotta know. Oh no. No. That's rough. So every caller saved register is pushed and popped for every single function call. And then the return value is stored in a Okay, I like this. This is impressively creative. I would never think of this. How did you honestly come up with this? Is this like from the book in the 90s? This is incredible. Told you it was horrible. You're correct, but it's amazing. It does work. I see how it works because every single function call has every caller saved register pushed and popped. It's good. It's good. Len's got the unactivated windows. Pepe. Who is that? Monka S. I always forget. Sraid says, I've been reading up on more recent papers, and those papers do take SSA form into account and talk extensively on how RA for SSA languages are implemented. Sraid says, I unfortunately have no excuse because I came up with this myself, lol. That's impressive. I would never come up with this. That's what I'm saying. Like, I could never think of it. But of course, he clearly bought FL Studio. Of course, of course. I actually did. I have the box for it. I know it's funny, but I actually did. That's one of them I did buy. Nick says no way. I promise. I would show you the license if I didn't if I trusted that it wasn't gonna dox me, but I don't trust. So oh no. I can't even think about this. It's okay. Everything is okay. Function call macro. That's beautiful. Just push and pop all the registers every time you make a function call, and that's a solution. It does work. I don't think I'm not smart enough to simplify it that much, but that does work if you're not worried about performance. Why are there assembly strings in the C? What? Because this is a code generator in a compiler, so we're emitting assembly. A compiler that's literally its job. It takes source code and emits assembly. That's how it works. Have you looked at like the C compiler that you use? This is what it looks like. You emit instructions into a file. Yeah, but like it does it with strings like that? What? What do you mean? Damn. Yeah, these are format strings. They're just basically %s is the format of a string, so it'll be replaced with this string value here. You can do like %d or %prid64, for example, and that will get you a 64-bit number. I thought it would use some high IQ thing instead of string substitutions. Well, you can, but in the gas, I mean, at some point you have to write a sequence of bytes into a file, and that is going to be a string in C. In C++, it may be like not a string, but in C it's going to be a string, because a string is just a char pointer, and that's a byte string, which in every implementation so far. Sarade says, I'm sure that there is a much cleverer way of doing this that involves coalescing and allocating different registers depending on whether there are function calls or not, but you mentioned that you wanted to continue working on the compiler, and I also want to finally get a state where I can generate code that works, and I will have less time for this now that Uni's starting again for me, so I want to get this done before that. Nice. Yeah, I see what you're saying. It's all good. Don't worry about it. I'm just saying it's really cool. I would never imagine this. So why don't you just like save all the registers that are allocated per function? Done. Not done, that is. Yeah, quoted done. I see what you're saying. It's in quotes. The air quotes have been felt as they have been written as real quotes. Oh, but it seems to me like you just save a list of registers that are allocated within the function you're calling, and then you would just save any caller saved registers that are also allocated in the function you're calling, right? Because then any registers that it clobbers that are caller saved, you have then saved. Sarade says its current thing, it always saves all caller saved registers right now. I know, but I'm saying you're doing it register allocation per function. So each function has a list of registers allocated to it effectively, or a set if we're talking in mathematical terms. So a set of registers are allocated to each function, or each function ends up with a set of registers that are allocated to temporaries within it, if we want to get technical. But basically, each function just keep track of the registers that are used within it, and then we could just save all the caller saved registers that are also used in the called function. And then in the callee, when we emit a function, we could just, exactly, save and restore callee saved registers. We could go through that list of registers in this function, and in that list of registers, if the register is callee saved, then we could just push it. And then same thing when we pop it. Actually, we'll just create a popped linked list. That way we can just pop off the popped linked list and then pop each value in the popped linked list. Does that make any sense? Because we're going to push them in a reverse order of what we want to pop them. So if we push them onto a linked list, as we push them, emit the push instructions, then that means we can just have a reversed list at the end automatically. Sarade says, of course it should only save caller saved registers that are actually used. Haha. Again, that's why it's quote done, not done. That's fair. This all looks very doable. A lot of this was here beforehand. We already wrote a lot of this, and then you went through with the indirect jumps and jump type names and instructions and went through and refactored all this code gen after we discovered the patterns within x86-64 assembly. So, or opcodes, I should say, rather than assembly. I think we can just start on our local branch. I think we're just going to start. We're just going to go from scratch. That way we can all understand it, how it's implemented, each and every part of it, and it's not confusing. How does that sound? Code gen. RPWH, I missed something. Yeah, watching compiler dev is like a crit hit for imposter syndrome. Lamau. Being a compiler dev is a natural one. It's like, oh man, I am not good enough to do anything. This is bad. All the code you write is like, this is not ideal. There's literally to-dos at every section. And it's not good, right? There's fix me. Should this null check create error rather than silently be allowed? Guess what? We know the answer to that one. Second argument is memory leaked. So this is a classic C code base, right? There's to-dos and fix-me's everywhere by multiple people. It's beautiful. Saraid says, also, if you just want a quick overview, the last section in the RA chapter is an RA example. We'll get there when we get to register allocation. Currently, our current compiler, I guess we should see if it works, right? So we're going to use like cmake, we're going to build, and then we're going to say what? Build slash, I guess just build. And then we're going to run build the executable within the build tree. And we're going to pass it the verbose thing, and we're going to pass it an example of like simple math. I don't have simple math, question mark? Is that not a file? I thought I had simple math. I guess it's not a thing. Huh. We'll just create it. Look at that. Did you check out the right branch? Are you testing your version? We are going from scratch. We're going from the main branch, baby. We're just writing it. We're going all in. So as you can see, we have an AST of 4 plus 4 plus 4 plus 4. And currently, this gets generated into directly this assembly output from this source code. How beautiful is that? You'll also have to implement the IR first. Oh, I know, that's where we're at. So currently, the AST currently, I say currently a lot because we're about to change it all. The AST is being used to generate code directly. So when we call CodeGen prepare call, we call into this CodeGen forward, CodeGen platform, not CodeGen forward. We call into CodeGen forward. Nope, CodeGen platforms. I'll get it wrong every time, don't worry. And when we call CodeGen call, what is it? Prepare call. Here it is. So you can see that it basically delegates to the different backend and says, okay, we actually want to prepare this call in x86-64 assembly. So to the code file that we have already opened, because we open a file during CodeGen, to that code file, we then write a program into it, right? I think my PR is like 40 commits and 5,000 lines changed or something like that. Yee. Also, while I was working on the IR, I found that having an IR simplifies things a lot. Surrey does like to lie when he says things like this. Sorry, it says the entire boilerplate in CodeGenPlatforms.c is just gone now. I know. You don't have to explain how it's going to be, because I'm explaining how it is. That's why I said currently a million times. And CodeGen.c is much simpler. It's arguable, yeah. It's arguable. It's also more complicated because there's an entire new structure you have to learn. It's okay. So what we're gonna do is, instead of generating a program given our program, our AST, right? That's what we're given. We're going to, as a first step, generate an intermediate representation that has some different semantics from the language that we are compiling, which is kind of odd to think about, how you can represent a program in a way that doesn't follow the same rules as the original program. But it will make more sense as time goes on, and especially as we get to implementing it ourselves. So what we're going to do is effectively when we call cogen program, this calls upwards to cogen program. Also, there's function names that don't need to be here. We're just going to say cogen file path cannot be known. Perfect. You can see that in cogen program, we are already doing gas-specific output, which is wrong. This is not correct. Because technically, what we want to have is cogen.c be completely platform agnostic. So for it to output to the code, it's a little annoying, right? Other platforms would get a little peeved and probably have many errors. One thing we are going to change is this. We're going to change the CodeGen context. We are in CodeGen. That's just the context. Parsing context, guess what? That's getting yeeted. And that is going into the CodeGen context. How about that? And then, when we, currently, where is it? It's in CodeGen platforms, I think. Currently, when we create the top level context, we're just going to pass in, guess what? The parsing context. And then all we have to do is when we set all this stuff, also set parse context. How's that? How about that? I'm liking it. So now it's mad at us because of multiple problems. First of all, we want to access the parse context here and the parse context here. Heyo. Saraid says, yeah, even my branch still has some gas directives, I think, or at least the backend does. Also, I've simplified some things, how context creation works and such. There's also some other changes in cogen.c. It's not just IR and RA. Oh yeah. So this is context code. This is now just context. This is now context. Parse context. Children. Going pretty well, going pretty well. A little bit of refactor. Never hurt anybody. Pretty good. So now we have context alone by itself, which we now don't have to pass this. When we create our context, we can just call it context. We can call this parse context because we are now in CodeGen, and that is something else. And we'll use it to pass it here, right? Why is it not complaining? I don't know. Probably because of the C file, or the header file not being updated. So we'll go to CodeGen platform and update it here as well. Because why not? And then we're gonna have to do some sneaky stuff, like including the parser, elemental PQRS. That's in alphabetical order. We are good. Implementing this from scratch is gonna take a while, just so you know. Yeah, we're not getting it done today. No chance. It's gonna be something though. It's gonna all be on stream and it'll work. How about that? Okay, so should probably switch on gas here and switch on the call convention, but it doesn't really matter. Just based on how the rest of stuff has been. I guess we should, we need to pass in the file. I don't know why I just went through and got rid of that. Does anybody else know? I don't know. Probably just because I had an error here. I was like, oh yeah, we're changing things. I didn't think about it. What am I doing? I got distracted. Too many arguments. I think you're wrong. It definitely was wrong. I just had to restart my language server. Lol. Okay, so we're going to try and build again. It still says output file path. And we still have the same code, and we can run it and stuff, I'm sure. Right, compile and run. Failed with code 16. That is what 4 plus 4 plus 4 plus 4 is, so that's a good sign. Soraid says, would you like me to work on this as well on a new branch and commit stuff incrementally? Do you want to do this by yourself on stream? I want to do this on stream, not just by myself, but I do want to do it on stream, which technically means only I can do it. I can host you if you want to stream while I'm not streaming, and I'm cool with that, as long as you are cool with sending over the video, the like 6-hour video of you coding, so that I can upload it. We'd have to figure that out. We're doing it for the people and for myself, because I understand things best slowly. And jumping in all at once and just going, here's a new code base, doesn't help, especially after a 10-day break. So we're going to slowly increment. What do we have? We have the working. It's not going to work very soon. So everywhere, if we take a look at a high-level overview, CodeGen program goes through every, it generates an entry point to the program, and then it goes through every basically node in the program and generates an expression. So what I'm saying here is that the AST looks like this program here. Ignore Emacs, highlighting things. So this program here has a binary operator node and a none node. So we will generate these expressions at the top level. So that's what this loop handles. And we do some register allocation and deallocation here, which is not a good sign. That'll change. Soraid says, oh, I'm not much of a streamer, lol. Not at all, actually. That's okay. You do not have to. So effectively, we cogen each of these expressions, and while we cogen these expressions, you can see that if we get up here, it's a doozy. For example, a binary operator, right? Let's try and find that. So here, you can see that we emit like a comment very specific to GNU assembly, and then say, hey, this is a binary operator of this, which is the plus, right? And then we say, hey, if it's a plus, then cogen and add, right? And do it with these two registers, because we've already cogen the left and right hand sides. So we go through the left side and the right side. And in doing the left side, we'll do the left side of the left side, and then we'll go, okay, we're done, do the right side. Okay, now this is done, now we can do the right side. Now this is done, we can do the right side. Then we get here, right? And that is effectively how the code generation works. And it works because x86-64 is kind of structured in this similar way, in that you have two numbers you have to add, and then you have to add a number to those, and then you have to add a number to those, and then you have to add a number to those, right? So in doing so, we have unintentionally made it very specific to GNU assembly. Because, for example, if the assembly worked even just slightly differently, it might be hard to reorder this in any sort of way, right? Imagine trying to reorder this tree and keep the semantics of the program intact. It's a very complicated issue and probably just wouldn't be done, right? So optimizations are almost out of the picture. You'd have to do peephole ones like, 4 and 4, those are two integer literals of a binary operator. We can just use that and make 8, and then the left-hand side, oh, this is 8 and 4, and we could do evaluation and stuff like that. But it's it doesn't describe the actual low-level intricacies of what the program is meant to do at all. Eternal Wildfox says, Soraid says, I mean, emitting the operands and then the instruction itself is a pretty general process. That's not just x86-64. At least the IR works like that too. Exactly. It's not that the IR doesn't work like that. It's just that the IR specifies that, and it makes it clear that 4 is loaded, then 4 is loaded, and then this is added. Whereas in this tree structure, it's not clear that this is the first thing that will be generated in the code, and it's not clear where we'd have to put it and able to reorder it, and if that'd be okay. Does that make any sense? I may have just said a bunch of nonsense. Let me know. Eternal Wildfox says, so I have a Win32 API window running with p-invoke in C#. I need native Windows, I assume, instead of .NET Windows. I don't know what any of that means. What is p-invoke in C#? And what is a Win32 API window? Are you saying just like a window created through the Win32 API with like the H handles, or what are they called? Handles? I can't remember what they give you. Display handles? So we're going to convert this into something that more represents the code that will be generated, or has to be generated, for the program to be to work. So Raid says, I mean, I also typically print the AST like you do, except that I format it differently and with colors. Yeah, that's too much work. But for an AST representation, that's just fine, I'd say. It's true, for an AST, it's just fine. For type checking, everything here is perfect. It's in the perfect order. But when we go to code generation, it's not in the ideal order. It's like, oh, we just have to do a bunch of these, which then have to actually do this, which then generates this instruction. And then we jump up here and do this one, and then it's like, it's so confusing. Eternal Wild Fox says, DLL import user 32. I love how you just copy and paste code in the Twitch chat. It's pretty legendary, Eternal Wild Fox. Yeah, he's using create window extended. So yeah, he's just using the Win32 API from user32.dll to create a window in C#. So he's doing like low level, oh god, public static extern int pointer create window x. Oh lord. That's a lot. Bless Eternal Wildfox, that's really cool. So instead of having this AST be what we generate code from, we're going to generate a different sort of code from this AST that can then be have some assumptions made about it, have some things that are definitely true. Like each value within the program can get its own temporary name or temporary variable. So for example, each of these 4s would be assigned a temporary. And that way we could say, okay, temporary 0 equals the integer 4. Temporary 1 equals the integer 4. Temporary 2 equals the add of temporary 0 and temporary 1. So then all of our references become references to other temporaries rather than references to literal AST nodes or values. So that's what we're going to do. How about that? So we're going to have code gen. We're going to have an intermediate representation, right? Which is this intermediate code. Oh boy, this is going to be fun. And then we're going to have an intermediate representation.c, which implements these things. And this is in CodeGen. So you can always take a look at my IR branch if you want to take a look at one possible way of implementing it. Absolutely. If we ever get lost, we're going to yeet code straight from your branch. Bless you for making it open source. Eternal Wildfox says, now I only have to get the graphics running. I will start with OpenGL. That's a large start. I don't know if that's only. That's a lot to do, Eternal Wildfox. But I assume you can do it fast. You do everything and quickly. So it says, I will say this, the assembly it ends up generating is a bit scuffed, just so you know. Ours won't be. Ours will be great, clean, and efficient. Vivax said, I don't know that, I'm just saying stuff. Vivax says, hey, what's going on, Vivax? How's it going? Thank you for tuning in. What is up with you? How is it going? So when we cogen a comparison, instead we want to have an IR comparison be generated, right? That's kind of what we want to do here. Also, this is horrible. Okay, we should fix all of these, because this is a little horrible. I'm going to fix the indentation in a bit, but we got to at least start with this. Code style is the most important thing. Everybody knows. Whee. How perfect. So an IR comparison, effectively, we're just going to have CodeGen platforms, right? All of these are now going to be IR instructions. So this is going to be fun. Suraid says, Suraid says partially because of the call macro. Partially. Vivak says, just working on a game. RPWH says, you using Bevy? Vivak says, yes. I believe that's the Rust game engine. RPWH says, yeehaw, bog bones. Suraid says, more or less, yee. Hey. I think that's in response to having to implement all of these. So we're gonna just, you know, do our thing. And we're gonna figure it out. So we're also gonna have some types. So we're gonna have an IR instruction, right? So we're generating this low-level code, and it's gonna have an instruction, which is gonna have an IR, yeah, let's give it an IR type. Let's make it an integer. We won't specify. And then we'll have type def enum type, like this. And this will say IR, like integer. I guess it wouldn't be integer, it'd be immediate. Because it's a little lower level, so we'd have immediates, we'd have accesses, we'd have stores, we'd have a lot of stuff. We'll get there. Implement types. RPWH says, you can't stop the crabs at Lens are one of us. Oh no. Oh no. That's Half-Life 2 all over again. Okay, so we're going to need a lot of types. And then we're going to need some structure that actually refers to a value. I think this is how we'll do it. We could do just a union. I mean, it is going to be a union. But I wonder if we should name it or not. It'd be interesting. Okay, so IR instruction, we have IR value. We might want to rename this, but I think it's fine. Because this is just refers to the tagged union part of it. And then there's going to be all sorts of things here. Like an immediate. Include int types, please. Why are you mad? Too many errors. Oh, just because everything CodeGen context and stuff. So we're going to need CodeGen .h. And that solves all of our problems. Wonderful. I would heap allocate all values, at least in my experience, that makes them easier to use because you might have to move them around later and such. Huh. We'll see. We will see. So these instructions are going to be within something called blocks, or basic blocks. And a basic block, a block is a list of instructions that are executed, I guess I should say that have control flow enter at the beginning and leave at the end. How about that? I need to find my... Yes, this will be nice. Okay, so a block is going to have somehow a bunch of instructions. Maybe we should just have like a linked list structure of instructions, or maybe instructions themselves should be a linked list. So we're just going to have instructions, and then we're going to have last instruction so that it's easy to add to the end of a block. And I guess we'll do this here. we're going to do a doubly linked list. Doubly linked list. Recursive? Not really recursive, it's just a doubly linked list. Nick says, just work in response to Vivac's just working on a game. What art style? I'm pretty good at pixel art if you want to do some stuff together, plus Rustation. Hey, that'd be awesome. Art is always hard to come by as a programmer. Soraid says, also there's all the vector macros in my branch if you want to use those, but those are more useful in the RA than in the IR. I'm gonna stray away from macros. I'm gonna let you know. I know it's gonna hurt your soul, but I am. We're gonna use less macros, because macros are hard to maintain, hard to understand, and it's like you have to relearn them every time. It's so horrible. There's all these semantics, and it's different between different compilers, and it's like, this is too complicated. Maybe we should just avoid it. So we're going to have as simple of macros as possible. Doubly linked list. So now we have a doubly linked list of instructions within an IR block. And then these IR blocks will be arranged within IR functions, I guess. And these will have a list of blocks where it has like first and last blocks, right? And I guess that means that these also have to be a list. So why not? Whoa. I forgot my Emacs command. To copy the current line, Control-Shift-CC, wrong number of arguments, move beginning of line. I broke something. Soraid says, that's the main structure, yeah. Hey. Vivac says, well, I suck at art, so just polygons. I mean, 3D art is impressive. Doubly linked list. How about that? So then functions, we're also going to have be a linked list. So how about they're all doubly linked lists? Functions probably don't need to be, but yeah. We're just going to have functions just be a linked list. I don't think we need an actual doubly linked list of functions. Because we just need the entire program to be a list of functions. We could also have like a typedef IR program. I don't know how this would go. Oh, struct. Which would be like a linked list of functions. Right? I don't know. We'll see. We're going to go with this. We're going to have, I think, the entire IR be passed around as a single function, which points to all functions in the program. Soraid says, even if you want to remove a function, you can still do that if you have a singly linked list. It's just a bit more annoying. It's true, you just have to go to the previous. You just have to keep track of the previous while you're looping. Vivac says, well, 2D polygons. Nice, triangles, squares, circles. I mean, there's been a lot of games on the App Store that are just spheres or circles, or like Agar.io was just circles and text. 2D polygons can make great games. Functions don't need to be doubly linked list. Love the asteroid style of games, though. Can't wait, says Nick1666. Awesome. First time chat from Verlio H. I feel like I've seen them before. Wait, circles aren't polygons, though. No, but it is a 2D shape. And they're generally able... I mean, they are polygons in computers. You don't draw a round circle. You draw a circle with a certain number of segments. So Verlio H, you are correct. Mathematically, or geometrically, circles aren't polygons, but computer science, circles are polygons. Verlio H says fair. Always fair, baby. So we shouldn't need to have like prepare call. We're probably only going to need one function argument. Add an argument to the upcoming function call. Sure. Perform call. We're just going to have IR internal call and IR external call. And these are going to create an IR instruction, insert it within the function, the current context or whatever. And then we're going to, just return that instruction. All the prepare cleanup call and the function prolog epilogue goes in the backend now, which is beautiful. That's where it should be. Also, goes in the backend is a funny statement. These are just all wrong. We're going to get rid of all the comments. Because they're all just going to be wrong. Maybe not all of them, but I don't think we need them. Ooh. Emacs is cool. Okay, so we have our basic structure lined up. And we're going to have to start filling it out. So how we're going to do this, so we're going to have an IR call value. Does it even need to say value? I think this just can just be IR call. I'm going to have an IR call. I know this is not perfect, but this is how it's happening. And an IR call is either going to be another, here's the thing, to reference another instruction, we're just going to use a pointer to the instruction. That's it. So it's going to be like all these instructions point to each other. And when we debug print things, we're going to have this notion of like IDs or numbers or unique identifiers. But truthfully, we're just dealing with instructions. So each instruction is referred to as a temporary because this is static single assignment. So every instruction gets a temporary assigned to it. Is the idea. Saraid says, no need to worry about any of that in the front end anymore. I know, it's beautiful. Saraid says, pretty much, yeah. Hey, I like when I get a pretty much from Saraid. That's like, I don't feel like I'm dirt like I normally do. It's like, maybe I'm like a rock in the dirt, you know? No, I'm just joking. Saraid says, that's why I said that virtual registers are just for debugging. Ah, virtual registers is what you're talking about when you say the debug ID. And I'm starting to get it. Callee. So this is the function we would call, or more accurately, the temporary. Ow! I just smacked my. Oh man. Words are hard. I just smacked my funny bone on the table. My pinky is all tingly. Okay. Oof. Eternal Wild Fox says, hell yeah. He's like, smack that funny bone. Yay. Sir 8 is F. Oh, thank you for the respects. I appreciate much respects. Oh, okay. So I'm just massaging my pinky. I totally just stopped talking. Eternal Wild Fox says console.writeline graphics processing unit plus Marshall pointer to string on C OpenGL.gl get string OpenGL vendor. Ooh, so you're calling GL get string from C#? You are spooking me. Eternal Wild Fox says, it works. I say hell yeah because of that. Hey, I see. You're calling OpenGL API from C#. That's pretty pog. Sorry, I appreciate the respects. My pinky is slowly becoming back to normal. Okay. I'm going to try and not hit my elbow again. I don't know what I was talking about. But a global function will just be called by a name. So this IR call struct can be a union. Actually, we only need one at a time. And it's basically just going to refer to, here's the thing. This is going to have to be a value in another struct. Also, this is why it's terrifying, right? So we're going to have IR call value, and this is going to have to be the actual function. Right, so this is going to be, I'm just going to call it value. I'm not creative. And then we're also going to have like a list of instructions. So we're going to have like a list of instructions, like arguments. So what if we just had an IR instruction list? This may be the way to go. Either way, I'm just going to do this for now. We're going to create an IR call argument. Also, I see things happening in chat, but I have to get something done. I'm going to type this and then I'm going to read it. Otherwise, I'm going to freak out. And this is going to be the argument. So we're going to have a pointer to the argument, and then we're just going to have an IR instruction pointer next. But this isn't an instruction pointer. This is a call argument so that we may have another argument following. Argument. What did I do wrong? Argument. There it is. E. Okay. Okay, Surraid says, this reminds me of that one time I had to debug some WASM, and the only thing that the browser would give me is error, some number. Guess what that number was? 420? 69? It was a pointer to a native C++ exception. Oh Christ. Took me a while to figure that out. So I had to write a native function that takes a JavaScript number, converts it to a pointer, dereference it as a standard exception to get the message, and then passes that back into JavaScript. Oh lord. Eternal Wildfox says, check Discord lens. Hey, here's the C#. So he's getting a pointer to a string from OpenGL getString. And it says GPU NVIDIA GeForce RTX 2080. Oh, damn. Way to flex, way to flex. Graphics card reveal. Verlio's right. Also, Verlio, you're in the stream. So good. That's really cool, Eternal Wildfox. That's really impressive. So you're calling OpenGL API from C#. That's awesome. That's very cool. We're going to have to forward declare a bunch of this stuff. This stuff. Uh-huh. Why are you mad? IR instruction list. Oh, because this is going to be IR call argument. And this is going to be arguments. So that's going to be arguments argument. We just call it value. Because then this is going to be when we're dereferencing it. It's going to be like call arguments value. I think that's fine. Sorry, it says you're type defing it twice. That's probably what it's complaining about. But that's a forward declaration. I have to type def it. This is the forward declaration. And then the type def forward declares this type as this. I think you can do it twice. I don't think that's against the C standard. I've always done type defs twice when I forward declare. You don't have to type def the definition. You don't have to, but for it to match, I just have the same syntax. You can do it, it's just not necessary. You're probably correct, it's not necessary. I just like everything to match. So you can look up type def struct IR function, and it's exactly the same. I don't know. You're probably right. I only need to do it in the forward declaration and not actually here. I just do things in the other order, where I write the struct and then the forward declaration. So this is how it ends up. But you're right, it's probably not needed. I could do this in a more efficient manner. if I knew I needed forward declarations ahead of time, which I probably could have guessed. So an IR value now may have a call. Okay, so this tagged union may have a call or an immediate, and the call is basically a call value, which is a union of a local, like an internal function or an external function, referenced by a symbol or referenced by an actual pointer to the temporary that loads the address of the function. Sraid says, also, just want to mention that because I think it's kind of nice, even if you don't like macros, I think my vector macro is kind of nice. If it didn't use typeof, it'd be great. That's my main aversion. IR. So, as you can see, all of these are going to convert into IR, and there are going to be some changes. First of all, this offset should be an int64t. But when we have register descriptor here, that's actually referring to an IR instruction pointer is the new thing. So, you know I love replacing strings. Register descriptor becomes IR instruction pointer. And look at that. The entire file has been rewritten for us. How beautiful. We're going to replace the string codegen context with just the word context, because we are in codegen. Allocate is confusing. It's going to be stack allocate. We're going to have prologue and epilogue, don't need those. Set return value, probably important. We're going to need to know in which function, though. Probably. We could just use the... yeah. We'll have to change codegen context some more. It's going to be a little interesting. These are going to have to go in codegen forward, aren't they? These are. So codegen forward is here so that everybody can have access to the same... whoops. The same structures, but they're only implemented once. So this basically prevents circular dependencies where the IR instruction needs to know about the codegen context and the codegen context needs to know about the IR instruction. So here we can have this included by the codegen, as you can see, codegen header, and it's not a big deal. We won't get I can't remember what they're called, but we won't get multiple assignments of the same structure because of multiple include statements and multiple headers. Woo! Saraid says, so basically like scuffed standard vector, but with macros instead of templates, though. It lets you do something like, I'm just going to copy and paste this. Vector char foo to create a vector. Yeah, and then you have like vector for each, I understand. It's just that it uses a GCC extension, which is fine. It's just not going to work on MSVC, which is kind of the goal for this compiler, is for it to work everywhere, where anybody can just open it up after generating a CMake build system. They can just blop, and it runs. They don't have to worry about third-party dependencies or anything like that. Yeah, I don't think we're going to need these anymore. We're no longer going to need to allocate or deallocate registers in this way. We're not going to need a register pool, I don't think, at all. So we could probably get rid of this. So we'll just say a to-do. And probably just get rid of this. We'll put it there. Why not? And yeah, this too. Right? Honestly, I just want to get rid of this. We're just going to get rid of this. Right? Yep. So sad. So sorry. Gonna be a big deal. Because now there are 1,500 lines of errors. Not even joking. right? How wonderful is that? Oh yeah, it's gonna be good. So maybe that should move currently. If I ever have to compile something with Visual Studio, I just use Clang. I mean, it's possible. It's just not the default. So people would open it up and it wouldn't work. And they'd have to go, oh, I need to use Clang. And then they have to know how to do that. And then it's a whole thing. Right? Versus just opening it up and it works. So we can probably just get rid of this. But there's much less errors if we don't. Right? So now it's just complaining that register deallocate doesn't exist, which is totally fair because we shouldn't actually be doing any register allocation or deallocation now, other than in register allocation, right? So this is honestly never going to be needed again, which is an interesting one, right? So we're going to have to go through and remove all of these explicit register allocations, which honestly isn't going to be that big of a deal. It's just going to be deleting a lot of what's already here. So we're not worried about that right now. It says undefined reference to IR comparison. So in codegen.c, one thing we did change was codegen comparison to IR comparison. It's now an intermediate representation. We're going to need to, honestly, I don't think we're going to need a cogen entry point. We'll get there. These are all just going to be IR, which we can probably just go through this whole thing and again change cogen to IR and be pretty good. So now it's saying undefined reference to IR comparison. So the linker, in attempting to build our compiler, is failing to find a definition, a body, a function body for the actual IR comparison, which makes sense because we haven't implemented shit. So let's go to intermediate representation.c and maybe begin to implement some things. And let's think about this. Okay. Okay. So we're going to have to add to the context first, because we need to know where to actually insert instructions to. So before, we just used the file and we just emitted code, but right now we need actually somewhere to store the intermediate representation in this cogen context. And that's what we're going to do. This doesn't make any sense. This is also going to change, but it's fine. We'll just separate that out then. And then what else? What did I just talk about? I'm very slow. So we need an IR function pointer to say function, and then we need an IR block pointer, block. Sure. Yeah. So now in cogen, when we cogen a program, we're going to have to create the main function first. So we're going to have to say like IR function context, right? So IR function is going to create and insert a new function. And then we can do something like this. Right? And then we can say main. Well, that's going to be an IR function. Yeah, okay, we'll see how this works. So in intermediate representation, so to create a call, that's what we'd like to do, but to create a function, We're going to have some way to do that. So we're going to have IR function. Pretty sure this will be good. Probably should just to do all of these, by the way. Here's what we're going to do. We're going to replace it with a new line, close paren, after a space, and then a new line, and then an open brace, and then a new line, 2 spaces, to do, and then a new line, close brace. Hey, legendary. Now they're all marked with to do. How beautiful. So now, hopefully, undefined reference to IR function. Okay, there's still one more. I forgot this one. Okay, now it's an undefined reference because I am a silly boy and I forgot to add this new C file into the CMake project. How funny is that? Redefinition of IR comparison. Okay. Why? Did I implement it somewhere else? I usually just use a glob in the CMake list.txt rather than adding each file individually. That way I never forget about it, lol. Yeah, that's not the safest. It just runs all code in the directory. So someone could put in any code. It's a little bit of a safety thing. So it says redefinition. Previous definition was here. Okay, there's literally just 2 because I copied it. That makes sense. There we go. So now we have in function, IR function to do. Would you look at that? So now we just have to actually implement this, and I'm pretty sure it's not going to be more complicated than this. Allocate a new function. Ensure that it went well. And if not, give a little error message. Could not allocate memory to IR function. And then what? Return function. We should probably say context function equals function. So should a function start with a basic block? Should a function start with a basic block? I don't know. I don't know. IR function. So when we use this, we're going to create the IR function. I'm pretty sure it should always just have a basic block right away. It's got to be. Equals block after block. Should have done both lines. First IR block of new IR function. Don't forget about if context function, function x equals cogen function or something like that. I'm saying because I forget that all the time. Lamau. Yeah, so basically function next, because it's a linked list, has to equal context function. That's all he's saying. That way, context function, if it's null, we preserve the end of the list, or if it's non-null, then we preserve the rest of the list, and just add this new function right at the beginning. Should a function start with a basic block? We could also add to the end, but I don't think it's important. Should a function start with a basic block? Yes, so allocate the first basic block. for the function. Because I think it should have at least one, because it must have a branch instruction, which has to be within a basic block, which means there has to be at least one. So what we're going to do, okay, IR block. We're going to have like block create. This is just going to be like a low level allocate and return. Doesn't really do much. May not even need the context. Yeah, we won't even take in the context. This is just going to be like allocate a new block after asserting it. So we're going to move this into its own thing, because I'm presuming we'll have to do it quite a bit. Whereas IR function or IR block will actually create a new block and then insert it into the current function. And IR function will insert it into the linked list of functions. This is all making sense. IR block pointer block equals IR block create. Let's allocate the first basic block for the function. Okay. Then I have to set function. I gotta turn on comload or something. I'm losing track of all these members. So function first should equal block, but only after block next equals function first. So we know this function is brand new. So first and last will be set to the same block. We don't have to do anything like that. So within the function, there's a list of basic blocks. And the first and the last right at the beginning will be the same block. I think this all makes somewhat sense. So we say function next. We're going to do this. We're going to do the same thing. I don't think it's going to be common, but we're just going to be consistent with the API. Thread says, yeah, the smallest possible valid IR function contains a basic block, at least one, that contains a return instruction, because return is also a branch and terminates a basic block. Nice. So we no longer have to specify what we're doing. It's kind of clear. Create a function, create a block. We'll say something like a function must contain at least one block. So we start new functions out with an empty block. We could even start every block out with a branch instruction that is just assumed to be at the end. I kind of like that. So what if this branch instruction is not in this linked list at all? This is the body of the actual block. So any instructions added to a block will go here. But every single block will have a branch instruction at the end. So why have it be in a linked list at all, an ordered list? We can have it be outside of that list and just be the branch instruction of the block, which is assumedly at the end. Would this work? That way we don't have to validate that IR blocks have branches at the end of them or do anything like that. We just know every IR block has a branch instruction from creation. And then as the block, if you're within a block and reach a return or a something like that, then the branch instruction changes. I don't know. We'll have to think about that. That is the branch instruction, not just the last instruction. So we're going to keep it like that as well. Right? So this is just before the branch instruction. And this is where we want to insert following instructions, the end of this linked list. But the branch is the end of the block and a whole separate thing. It's going to make sense. This is going to make sense. So when we create a block, guess what? Okay, we're going to do a macro. It's going to happen. It's going to be instruction. And it's going to have a name and a type. And it's basically just going to do the thing. So we're going to say IR instruction pointer name is equal to calloc1 size of IR instruction. Assert name could not allocate new IR instruction. Because we're going to have to make these instructions all over the place. We could just make this a function as well. There's literally nothing stopping us. And after we assert name, then we want to say name. Also, I should probably put it in parens just in case. We're probably going to have to not name this type. We're going to have to call this like given type. That way it doesn't think anything of this type word here and try and replace that. So now we're setting this new instructions type to the given type. Hey, look, a macro. I think we did it. So now, when we want to create a new instruction for this new block, we can just say instruction. It's going to be an IR return, I guess, would be the idea. Which is going to be something here. Perfect. And then we're going to call it first. I don't know. It doesn't really matter what we call it. So first is going to have no value because it's just a return. So then we're just going to say block branch instruction equals first. Okay. And now what we can begin to do is the same sort of thing that we did in the intermediate representation where we go through and replace code gen calls with IR calls. How fun. There's also going to have to be some stuff done here. It's fine. Everything is fine. This is going well. I think we should work on a way to debug the IR, and then we will be on our way. Okay, so we're going to need a void IR print. Let's have it be IRF emit, so that if we want to emit it to a file, we can do that. And then we're just going to say, pass us the whole context. And then we're going to have f-emit function, block, and instruction. And as we go, this will be an IR function, an IR block, and an IR instruction. How beautiful. Okay. Okay, so now we're going to take all of these and implement them in here. Okay. And so to f-emit an instruction, we'll basically just be switching on the instruction type and then handling cases. So default to do handle IR type blah. How's that? And then we can handle like an IR immediate and say this we will print to the file the instructions value immediate. And this is going to be percentage pride 64. So this is a int 64t, a 64-bit integer, so we need a 64-bit format, which is what this refers to. And upon doing so, we will have printed it. But this doesn't really help us a lot. It doesn't tell us which instruction this is, it just tells us what the instruction is, right? So what we're going to have is a little bit of a debug. Mr. Coulter says, can you do away with IR block and IR function and only use IR instruction? No. Yes, but you would have to change how the intermediate representation works. Do you like my multiple answers? Here's the thing. I know it seems like way too complicated right now. Why do we need all these things? And the answer is branching. So how would you do branching if it was just a flat list of instructions, right? You'd have to branch just to another instruction. But then how would you know if that branch is like a return from a function or if it's anything, right? There's no organization if it's all just instructions. So block and function are simply organizations of instructions. They won't actually generate any code in the final output other than being grouping together instructions or generating like, oh, there's a function here to jump to the beginning of the function, put a label. But it has mostly to do with branching. So an IR block handles all the branching between blocks within instructions. Also, there's something we should handle for control flow. We're just going to give it the same name. So a predecessor, if you don't know, something, this is spelled wrong, predecessor, is something that comes before something. So an IR block predecessor is going to be an IR block, which is a predecessor. It's just, we're going to call it a block here, but it's a predecessor to an IR block. It's going to be a linked list. And each IR block will keep track of all the predecessors that the control flows that reach it. And in this way, we are able to follow control flow, as well as in other ways through branch instructions. But this is for control flow analysis, really, CFA. But Mr. Coulter, with your first time chat, you are absolutely correct. You can do away with IR block and IR function. It just means that branching is going to be very complicated, and there will be no optimizations that you can make due to this reorganization. And that's kind of what we're doing it for. We're creating an intermediate representation so that we can organize the code in a way that better suits a multitude of code generating backends, like x86, 64, rather than having to have specific register allocation, rather than having to have like specific AST traversal. So there's literally like tree traversal that has to be thought of when you're writing a backend in the current state, because you're generating it from a tree, from an AST. So our solution is going to be, don't create a tree, don't generate it from a tree, generate it from a flat list of instructions that are organized into different blocks that can be branched to from each other. And then all those blocks can be organized within functions, which can also be branched and returned from with a call. Mr. Coulter says, I see, IR function is composed out of IR block, and that is composed out of IR instruction. Absolutely. You have nailed it, Mr. Coulter. But yeah, we're just going to add the predecessor so that for control flow analysis, we can follow it backwards. Which is going to be important in a while, but not now. So when we print an immediate, it'd be nice to print the number, which is what this does, but it'd also be nice to print not just the number. Would you agree? Also probably a new line, right? So we want to have each instruction have some sort of identifier. So I'm just going to give it an ID, is what we're going to call it. This is literally just for debug purposes. Well, nah, we're just going to have this be a unique identifier. for each instruction. And this is mainly for debug purposes, but in register allocation, I think, well, we'll probably just create an instruction list and have indices. But we could just overwrite. Yeah, so here's what we'll do. We'll have index. This is going to be for register allocation in the future. Don't worry about that. This is going to be for like debugging. It's just going to be a unique identifier, mainly for debug purposes. I feel good about that. We'll get to register allocation with a better description there. So with this ID, we would like to print it out for each instruction. And I think we may use a macro again. No, not a macro, but just a preprocessor directive. I think we're going to define the ID format and then undefine it in this little section of code here. And the ID format is just going to be a string, which refers to how we print out the instruction's ID. So we're going to do a percentage and then a number. So this %% will format into a single percentage sign, and then percentage %zu will format into a number we're going to give as instruction ID. And then we would like to print into a fixed size buffer. Can we do something like percentage 8zu? Yeah, can we do something like that? Right? So if we did percentage, and then percentage 8zu, let's do 7, let's do 6. Then we could just put this ID format here, and that will print it. So why do I want to do this? Because I want to write justify the numbers. Okay. I know what to do. So in order to write justify the numbers, we're going to have a const size t ID width. And this is just going to equal 10 for now. And this is complicated, I know. It really doesn't need to be. Then we're going to say size t ID length is equal to, we're going to use snprintf with null and 0. That way we can just get the length of a formatted string. Sorry, it says Ascii, we're printing instructions. Yeah, we are. And then we're going to say, oh boy, difference. Okay, this is going to have to be an int64t. Difference equals width minus length. And then we're going to say while difference, put char /n. Nope, not /n, space. And then we're going to printf. Also, this is going to have to be putc. That sounds funny. It's in the wrong order. And then we can print out the numbers and the rest of the thing. So basically we write justify this number. Does this make any sense? Sorade says, is there any reason as to why you're printing to a temporary buffer? We're not. We're using snprintf here to get the length of the given number. That way we don't have to do like divide by 10 or modulo 10 and figure out that stuff. Mr. Coulter says, do you have experience with LLVM? I have none. Sorade says, I do, but I'm not sure Lens does. He's correct. You can also get the length of a number using log10. Yeah, that's what I was just describing. Basically a manual log function in C, where you loop over, get the modulo of 10, then divide by 10, then continue. Because you change the magnitude of your division every time, so it works out to be the logarithm. It doesn't matter. It doesn't matter. But the I'm pretty sure the width minus the length is equal to the difference, the amount of spaces that we need. So now we just need some way to actually set the IDs. So we're actually also going to have that. And this should only ever be done like once. right? Once we build the context. I guess it may be if we rebuild the context or add things to it, then we may want to set the IDs once again. So we set the IDs, which just means, here we go, for every function within the context, until it is null, it is equal to the next function within the context. This is a for loop, which traverses a linked list. Now, we're going to have two more. I know, it's ideal, right? But this one is not going to be function. It's going to be block. And this one is not going to be function. It's going to be instruction. And all we have to do is, instead of using context block, we use function block. And then instead of using, also it's probably first. And then instead of using context instruction, we use block instructions. And now, also, oh, I totally skipped all these. Oh, this because this is an f-emit. We're doing good. Saraid says, I also made a list for each macro because you have to deal with this sort of loop a lot in the IR and RA. Yeah, I think I'm just going to keep it as a for loop. It's fine. It doesn't really bother me. We can macro it up if we really want, but I'm not peeved about it. So now we just have to set each instruction to an ID, which is just going to be an IR instruction ID that's like static. That, right? Here, we'll just increment it so that we don't use 0 ever. Yeah, we'll say instruction ID. And it's equal to 0. That's what it starts as. We'll increment it and then use it as the ID. So now every instruction gets the ID. Sorry, it says, I just like for loop macros. I think if you remove for loop, then that sentence makes sense. No, I'm just messing with you. Sorry, can you tell that I'm more of a C++ programmer these days? Haha, definitely. So after we set the IDs, that means that each one will have a unique ID and we can print it out all nice-like. So now in CodeGen, when we're actually generating things, okay, yeah, so before as well, okay, there's another thing we're going to change just initially. Nodes before stole their result register for register allocation. No longer do they do that. They will now store an IR instruction pointer, which refers to their result, or the temporary, which stores their result, if that makes any sense. And we're going to need, again, CodeGen forward to avoid circular dependencies. So with that, we now have the result, which can be stored here. I'm just going to reorganize this a little bit. It doesn't matter. It's going to be like a tree structure. Tagged union. I love that we've gotten away with just integer and char pointer so far. We're going to use standard ints instead of implying 64 bits with long. Perfect. Mr. Kutler says, what's your opinion on writing this kind of project in Java versus C++? Both are going to turn into object-oriented messes, so pick one. Saraid says, alternatively, you can also forward declare it in the declaration struct IR instruction pointer result. That's true. That doesn't always work in C++ because namespaces, but it's just fine in C. You are correct. You are correct. I think this is fine. Including CodeGen forward is going to be needed anyway later. Or at least it may be, depending on how we do local variables. So now, result register doesn't exist, and these should now say IR load immediate instead of the other thing. So now we have to also include it. Hashtag include intermediate representation. And that's in CodeGen. CodeGen.h is complaining for some reason. What's happening? There's too many errors. Oh, yeah, just lots of stuff to do. We're good. So we can get rid of these. No longer need register stuff. Okay. This is ugly. Should this be heap allocated? It's just a string for the error. You should probably just assert here. Like print error and assert 0, right? I don't think that would be an issue, right? We could even just print f. It really doesn't matter. Printf to standard error if you really count. If you really care. It doesn't matter. Saraid says, personally, in response to Mr. Koter with Java or C++, I loathe Java, so I'll always choose C++. Haha. That said, I also like C++, and LLVM is written in C++ if you want to use that. There are C bindings for it, but they're kind of jank, to be honest. Yeah, it's hard to find just a what am I trying to say? Oh, a compiler that's written in just C, which is partially why I created this. I was tired of having all of them made in C++. It's like, you can do this in C. It's honestly easier. This should probably be like symbol address. This is going to get to me. We don't use ever camel case for type names. Not camel case, snake case. We only ever use camel case. Pascal case, if you prefer. I guess camel case has the first one lower. We're also just going to do this. Out dot error equals okay. Equals symbol address mode error. Sure. Okay. Just reorganizing some things. That'd be bad. Error. Okay. I don't know why I took the time to do this out of all the things I could do, but apparently it was important to me. This is all going to change anyway. It's not like it matters. I mean, it's not going to change that much. This just isn't going to be an integer address anymore. Heyo. Perfect. So now we have a bunch of issues with result register, which is exactly what we want, because it should just be result. And this should be IR. Okay. So we're going to add a function argument. And it should be... Did I replace everything in here as well? I did, right? So IR add function arg. See, it still has register descriptor. Argument. Mr. Coulter says, I've been hating Java boilerplate more and more, but I always have a hard time with C++. C++ definitely takes some getting used to. Yeah, that's another reason I don't like Java. I can't stand camel case. Pascal case is fine, but camel case is an abomination. Lamau. Strong feelings. So do for iterator equals iterator next child. Convert this from a while into a for loop if we can. Because why not? Okay. So cogen the expression and then add this function's result, this temporary, as an argument to the function. You don't need to prepare call at all. You should probably have like a comment thing here, right? We'll just deal with comments in the back end. I don't know. This is going to be an interesting one. How to deal with comments. We could just make a comment another node type, another instruction type, I mean, and insert them as well. We may just get rid of them for now. It's not like they're needed. Okay. Mr. Coulter says, any experience with generating Java bytecode to run in the JVM? Sarade says, well, it's a stack machine, so it's probably not that difficult. I've never generated JVM bytecode by hand before, though. It's probably not that difficult, like Sarade says. Just figuring out what opcodes do what and what their values are, and then creating a little program that emits them in the proper order. Seems doable. So we're not adding to the proper thing here. So when we add a function argument, we're actually going to have to know which function we're adding it to. Which is going to break things, because this is going to have to go above now. Do we even use this anymore? I don't think we use this anymore. And now instead of doing, oh, that's when we used it. Nice. It was in what I just copy and pasted. Hilarious. Yep, I'm going to need these things and to put them here. And I'm going to need a function. Do my little trick so I can make things. Okay, so if it's an external function, and we want result to equal IR external call, else it's equal to cogen expression, and result is equal to IR internal call. Does this make sense? So if it's an internal function call, we want to cogen the actual expression so that we can access this function. I think this makes sense. Does this make sense? I don't know if we need to cogen here. Sarade says, I mean, it can't be worse than generating x86-64 jump instructions by hand. That's true. You did pretty great at that. Better than I did, 100%. In the Discord, we got some discourse going on I'd like to check out. What do we got? Not the meta thing. So is everyone here a programming language nerd? Lamau, you knew. Yes, apart from me, I'm stupid. Sarade and others are super advanced gigachats. Oh, I'm very stupid as well. We can stick together. I just like making my own language. That's where I'm at. It's just a compiler. From scratch for fun. Sir Aid says, nah, I just have a bit more experience, perhaps, when it comes to compiler development, at least. Nick says, yo, no way. Me too, except only interpreted stupid shit. Lamau. I get what you mean. It's all about effort. If you spend 2 weeks on it, I'm sure you will get very good at it. So we have IR internal call and external call. Do we need this code gen? Do we need this code gen? I don't know if we need this code gen expression call. Because we already set expression result. But this is expression children, so we do need this. Yeah, okay. Okay. So now we have expression result as our function. No, it's just a function call. So when we add a function argument, we're adding a function call argument is a better name for it. Add function call argument. Sure. So it's not going to be an IR function. It's going to be another IR instruction function call. You can just call call. Yep. Add function. Add function. Nothing. So we're still just going to have to create it. Yep. Again, we should probably get into printing more, but we'll get there. A little busy right now. RPWA says, "J'ai retourné." J'ai retourné. I don't speak French. I think he means he's back. How's it going, RPWA? It's so good to see you. So when we add a function call argument, we want to say call. We basically want to add to the call value call arguments linked list. So we should say while arguments, I guess 4 arguments, arguments equals arguments next. And then we're going to say while arguments next, actually. So when we get to the end of this, arguments next, we can set to, yeah, so when we get to the end of this, arguments next will be null. So we can set it to our new argument. Hey. Apes together strong. Yes. Apes together very strong. Oh, I don't know how to use Discord anymore. It's been so long. Hey. So we're going to calc this. And then we're going to return. I don't think we need to return everything. Or anything, I mean. I think this does it. We could also just add to the beginning of the arguments list, but that would not preserve the order of the arguments, which is what I'm worried about. I want them to stay in order. So we add to the end of the linked list. Okay. What's it mad about now? Implicit declaration. That's got to be a just error, yeah. So the idea is we cogen. See, interestingly enough, I feel like we shouldn't do this here. I feel like this should happen down here. So we're going to say if it does not equal think this makes sense. So to actually calculate the address of the function we're calling, we do that after we calculate all of the arguments. I think that makes somewhat of sense. Yeah. 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 Lots of issues here. Oof. That's an old one. Okay, so we're going to have IR load global address. We're not going to have any idea of into. That's not how that works. So we're just going to have load global address, right? And then this is going to set expression result. So the result of a function expression is the global address of the function. Does that make any sense? I think that makes sense. Also, if error.type return error, we totally forgot right there. Okay. There's probably also some other things that are going to have to change. But I don't know. We will see. We will see. Maybe everything breaks. Maybe everything breaks. So a dereference is horribly broken. So this would be like an IR load, right? So a load instruction is going to take an address, which is going to be stored in some temporary, and it's going to load from it. So we're going to say cogent context, kind of writing this here temporarily. I'm just going to put that there temporarily. And we're going to say IR instruction pointer address. So this will generate a value which is at this address. Is this enough information? Load address. Do we need like IR instruction size? Nah, this will be good. So load address. That's what we're going to have to do. So I'm going to need this portion. And this is going to change a little bit like this. Yes, I know. And then this is going to be this thing. We'll use the kill ring and have everything work out. So now IR load is going to return an instruction. And it's going to say load an address. Guess I'm not doing that here. It's going to say load an address. I think this is how this will work. Intermediate representation.c. Okay, so in IR load, we will say to do. We'll create our little format. Okay. So the idea, okay, we're also going to need insert instruction. There's so much to do. So given a context, we're going to want to be able to create a new instruction. So what we're going to do is kind of have it like here. It's going to be IR instruction pointer, IR instruction. So this should, what? What am I picturing here? I guess I should have a function for inserting an instruction. IR insert into the current context. I think that would work. So IR insert should say context block. Oh, also we're gonna have to know if a block is closed or not. Otherwise we'll just always be in one block. So an IR block basically will continually have instructions fed into it until it becomes closed, which means that you don't have to worry about adding to it anymore. So we can say, if closed, we should probably generate a new block here. Our block, insert into that. Will that ever happen? I don't know if we're ever going to try and insert into a closed block. So let's maybe not deal with that here. We'll just say context block, last instruction. Okay, so basically, we have this block. So it says, Mr. Coulter says, will you be able to loop over this IR and run the instructions? Saraid says, that's possible, yes. Mr. Coulter, we could loop over any part of the program. It doesn't work anymore, but if you were here earlier, when we were looking at the AST, we could loop over the AST and evaluate that or interpret that at runtime instead of generating code from it as we did before. The intermediate representation, as it is just another representation of the AST, will also share that property. So we will also be able to execute these instructions as if they were a bytecode or their own instruction set, which is also kind of the idea. Sorry, it says, Len's probably already answered this, but I was a bit distracted for a moment. Actually didn't. Sorry, it says, if we ever make a tree evaluator, we should call it TreeVal. That's just too funny of a name, no, lol. I like it. I'm cool with it. So we're inserting into this IR block. So it has a last instruction, and we want to set the next of the last instruction to this given new instruction. We then want to set the last instruction to the new instruction after setting new instruction previous to the block's last instruction. How about that? So the last gets a next. So again, linked list style, right? You have a terminator or like the end. So if we're trying to insert into the last instruction here, then you can tell that its next is going to have to be new, right? And then we have to say, because it always points to X and we're adding to the last instruction, we don't actually have to do that pointer swap because that's already null. So we don't have to swap this next to this next because they're null. But new previous this way, right? Because it's a doubly linked list, if you remember. That means that new previous now has to be what was our old last instruction. So new previous is the last instruction. Last instruction next is new. And then last instruction is now equal to this new instruction. I think that's all the updates we need to do. Right? I think that's it. A little more understandable. Mr. Coulter, will this support multiple threads and data creation at runtime? I mean, yes. You can already call out to external functions. So like you can call to libc. So if you take a look in our examples, we have external function. We can define an external function. Here, I can even get syntax highlighting. Yay. So you can define an external function with the ext keyword, and then you can just call it, and as it'll still type check all the arguments and return values and everything. But for example, putchar, which prints a single character to standard out, this prints A. There's no reason that you couldn't have a pointer to an integer or some other type in the language, right? Created or returned from something like malloc, which takes in a size integer. And then you could call malloc with a size and assign it to my heap allocated integer or whatever you would like, right? And you could have it equal to malloc. So data creation at runtime, sure. Use the C library, link with it. Use malloc and free. It's not going to be built into the language at all. That's going to be up to you. It's going to be a low-level systems language, effectively. I do, Sir Aid, I keep looking at TreeVal. I do really like it. It is something we should work on. As far as multiple stacks or threads, yeah, that's something I think is better handled in a more mature language like C or somebody else. I'm not willing to deal with all that, I don't think. IR insert should not return an instruction. It should just return nothing. Yeah. It should just do the insertion. Lamau. That's what she said. I'm such a child. Okay, so we have this block, and honestly, we don't even need to get it into this separate thing. We can just say context block. It's really not that bad. Why are you mad about IR insert? Because it takes in an instruction that it doesn't know about. Okay. Lots of problems still. That's wonderful. And yeah, just fill these with to-dos so that we don't have functions being called that are just empty. I know they're not called anywhere, but as soon as we do, it's going to be confusing. So adding a function call argument, there's nothing actually inserted. We were talking about a load. So we're going to have an instruction, which is a load, and it's an IR load type, right? So we're going to need an IR load, which is just going to have, I guess we can just do IR instruction pointer reference. So when an instruction has a value of reference, it references another instruction. Don't think that's too complicated. So now we can say reference is equal to the address. And then we can return load after inserting it. Oh god. What is happening? Isnert. I'm smart. So then we call IR insert on context and load this new instruction. And this will insert it into the current block at the end. We should probably also have like IR insert before and IR insert after. But this is pretty good. So we update the next and previous, we update I mean, we have I think we update all of we handle all of our cases. Perfect, perfect, perfect. So now we just need to start going through code gen some more and dealing with this. So IR load now exists and isn't a problem anymore. This we just named symbol address. I got tired of looking at the snake case for the type name. This can just be result. So when we say codegen load global address, I think that makes sense. Sorry, just handling a text. Okay. So it says, by the way, if you have anything you want to ask about my branch, if I don't answer for a while, just ping me on Discord. I'm kind of dealing with another project right now, and also I'm having dinner, so you're doing so much. Well, now, no problem. Thank you so much, Sir Aid. I very much appreciate that. And I will keep it in mind. We should be doing good here for a while. And yeah. We're probably going to end the stream here pretty soon. I don't have as much time as I'd like to today, but I'm so glad I've been able to stream again, because I've been tired of doing nothing. I feel like I've just been helping other people, and I haven't actually done anything myself. Cogent add immediate to expression result. Offset memory address by index. Yeah, this is going to work differently. So this offset is a number here for our array access, for our array index operator. So we're trying to add the calculation to get the offset address. So what we would like to do is just turn this into an IR add and create IR immediate to load offset into temporary, and generate an add between the new temporary and the result of loading the array's address. Honestly, I wonder if we can't simplify this whole process. I am curious by that. Okay. In any case, battle to do there. And we're just going to do this for now. We're just going to do this. That way we see it next time we run it. And, yep. Good enough for me. Doesn't look good, but it's fine. That's our to-do. No more gas-specific comments, please. Okay. Lots of stuff is going to have to change in the if. This is, okay, so the if is where a lot of stuff goes wrong, because this is where complex branching happens, and that's the most complicated position. Sir Aid says, by the way, should I close the PRs? I'm still going to keep branches around either way. Feel free to close them if you'd want, yeah. Sir Aid says, one option would be to deal with variables in the IR instead of the front end. Oh, so you're saying have temporaries allowed to be named and used multiple times, which would break SSA, right? Which isn't a problem. By the time we end up generating code, we break SSA a million times. Soraid says, haven't implemented that in my IR branch though, that's just an idea. Soraid says, yup, basic block and phi time. Actually, basic blocking, phi time. Also, is it phi? Am I an idiot? And is that pronounced phi? I gotta go look now. I've been doing a little bit of linguistics because I'm creating my own, like, spoken language, a naturalistic one. Also, Mr. Couture, thank you so much for the follow. Soraid says, no, you're pronouncing it correctly. Oh, that's good. How's it, what is it in the IPA? I'm actually curious. Phi. It is phi. Okay, so you can see that it's kind of small here. Where do they reference? The Oxford English Dictionary. Which... Is it a link, or is it just a generic Oxford English Dictionary reference? It's just a generic Oxford English Dictionary reference. Okay. So it says in English it's phi. Yeah, that'd be phi, because the AI create... if we look at the help for English. But yeah, I've been creating my own language, so I've been looking into IPA and trying to define... Am I an idiot? I am. It's right here. You can see that AI is the I in price, or the IE in pi. So FAI would be correctly pronounced phi. And F is like a unvoiced fricative or something. I don't even remember. I don't remember. I can never find any of them. There it is. Doesn't it have... There's a name for it. I can't remember. In ancient Greek, it's phi. I see. Voiceless fricative, but yes, bless. In ancient Greek, it looks like phi with the lowercase I. And I've never seen that little bitty h up to the side. I'm kind of scared about that, boy. I did linguistics for a while, and it's still a hobby of mine. Awesome. I'm creating a new language, so that'll be fun. I may be asking you for help. Where do I put add positions? This is no longer going to work at all. Yeah, this is all just going to have to change. Okay, generate if condition expression code. That can stay the same. Generate code using result register from condition expression. Yeah, not going to work. So generate if condition. Generate if branch to two different basic blocks. Can generate if branch on condition expression result to two different basic blocks, then and otherwise. Sir Aid says, I actually moderate a conlaning YouTube server, haha. Well, a Discord server for a conlaning YouTuber, that is, haha. That's awesome. Which one? Is it like a Biberidian or what is? Or what's the other one that starts with an A? RPWH says, how do y'all find the time? Shaking my head. You know when like you're talking to somebody and you don't give a shit about what they're saying at all? That's when I find the time. You know when they're just talking at you and they're telling you, on 9 a.m. on the second day of the 3rd month of the 100th year, I went to the store and this man in a blue coat with long legs and short hair told me that I have... And it's just like, I lose track and I start to think about other things. And that goes to like, what if a language had one of the rarest default word orders in the world? Because it actually makes sense to me. And that's what I'm going to do. Do we need labels? I don't think we need labels at this point. Sir Aid says, Egma Schwa. This is definitely the first time I've plugged Egma's channel in a programming context. Well, I'm into linguistics. You'll get me there. Welcome. Okay, I gotta check this guy out. Ooh. He does conlang showcase aesthetics. That's cool. I like writing systems. This looks awesome. I'll check it out. Ooh, back to Lange. Lanning? Lane. That's an N. That's a fancy N right there. Okay, I'll check it out. Hopefully he's not like super racist and you're just not telling me. That would be horrible. No, I'm just messing with you. I would assume he's not. I just always get worried showing other people on my stream. So it says, nah, he's nice, Lamau. That's good, that's good. To do, generate if branch. If instruction. With then and then otherwise blocks. Okay. Enter if then body context, generate then expression body. Don't do any allocation. Complicated, but it'll work. And then we can say generate code to copy last expression result register to if result register. This is our phi node handling, our phi lowering. Hilarious. So to do nothing actually. Just generate a branch to the generate an unconditional branch to the join block. So effectively, so we're going to have like our current block. We're totally doing this, by the way. Okay, how long does this need to be? We're doing ASCII art. It is happening. Okay, all of this, I would like to point to yet another box. And this is going to say then. So control flow wise, this is the block diagram that we are creating. It's probably gonna have to be quite far over. Hey. Saraid says, hey, that's legendary. Saraid says, also, you're not the first programming-related content creator who's mentioned conlenning, so it seems that there's at least some sort of overlap there, haha. You mean language design? Has to do with language design? What? Saraid says, but yeah, if you have any linguistics questions, just let me know and I'll try to help. Blessed, you're the best. Also, RPWH, you're awesome for spotting them in the Hyperpirate description. That's legendary. What a shout out. Yeah, Eternal. Mr. Coulter says, next level documentation. Hell yeah. We have to. Otherwise, I'll forget. I have the memory of a goldfish. We know this. Right? Yeah, then these both, like, join. Yeet. Yeet. Pretty sure it's gonna have to be 6 long to fit join in the middle. I was right. Each is a basic block. Is a basic block within intermediate representation. And edges represent control flow from top to bottom. I should say each something, each box is a basic block. It's gonna break again. Hey. Saraid says, yeah, I help Agma with stuff here and there. Typesetting Hyperpirate was an experience. Oh no. Gumsmack was worse though. I had to create my own shaping engine for that, basically. Lamau. Yeah, I'm not screwing with glyphs. I'm gonna choose the glyphs that humans have chose, which is Ascii. I know American is in the first word of that, but I'm gonna use like a generalized American symbols, Ascii symbols. That way it can be typed. That's kind of a requirement for all the languages I create. They have to be typed. This is perfect. This will help us a lot in the long run, figuring out how this stuff works. There's going to be a lot to do. To do nothing actually, just generate an unconditional branch to the joint block. So before we would lower the phi's, but this is actually going to happen at a later time. So we're going to say IR branch within codegen context into the join block. So you see we have IR branch, and instead of it being a specific label, it's just going to be an IR block. Destination is what we'll call it. And branch if, we'll do branch conditional is what we'll call it. And we're basically going to have an instruction which refers to a temporary. We're going to have a block which refers to our then and our otherwise. And that should be good enough for us. There may be something else I'm forgetting. Either way, we should now go implement these in Ascii so that we don't screw everything up. We don't need IR branch if 0 because you can't have multiple branches in a basic block. So the if branch has to be a singular instruction. Sarade says, also, since this is relevant for you now, if you ever want to typeset linguistic stuff, especially IPA, I would really recommend using Ascii LaTeX, since typesetting IPA with PDF LaTeX is painful. It just lets you use the Unicode directly instead of having to use LaTeX commands for all the non-ASCII characters. That's probably worth it. I agree. You're probably right. I should switch LaTeX distributions. It's just hard. Mr. Coulter says, is there an MS Paint for ASCII art? Yeah, it's called Emacs. I'm in it right now. No, I'm just kidding. But seriously, it is called Emacs. Do you want to see what it can do? That's a block. Oh yeah, do you want to see what it can do? Let's open up a temporary buffer and just open up artist mode. And here I have to do this to show you. But you can just middle click and choose all these different, you know, tools, like a spray can. So if you want to make like some ASCII art, right, with like a paintbrush style, you can do that. You can draw straight lines, right? You can draw, whoops, accidentally closed Emacs. You can draw, what do you want? You want like a rectangle, an ellipse. You can draw ellipse of any size. You can use, what else do we have? We have edit. You can like cut, copy, paste, and flood fill, but that's a little complicated for right now. You can vaporize. I've never actually tried vaporize. I don't know what it does. You have polyline, so you can create something like this, right? You can create polygons. Whoops, didn't quite get to the end then. Pretty cool. Sarade says, of course Emacs has an ASCII art paint mode. Every good operating system does, after all. It's true. But yeah, there's also a pen, which just draws simple dots. There's my name. Right? Emacs would be your best bet. Mr. Coulter says, I have seen the light. Yeah. I'm glad. But yeah, artist mode in Emacs would be the closest thing I can recommend to you. Okay, still just going through CodeGen. So I don't think we actually need these labels anymore. Yeah, so this is like, should go here. But it has to go here, because we have to initialize the blocks that we're branching to first. Generate if instruction with then otherwise blocks. Yes. Generate an unconditional branch to the join block. Generate otherwise. I don't think we even need last expression anymore. Copy last expression result register to if result register. So that's handled by the phi. So we just have to say generate branch. Well, we can just do this. IR branch. And IR branch of to the join block, because this is the end of the otherwise block. Else, we zero out the result register in this block. So if there's no body, basically the otherwise, if you don't provide an else, it'll just zero out the result. And I don't think that's a bad thing to do. So to do IR0 or something, zero out result, or just trust, right? How do we deal with this? We need IR0 or maybe IR XR. We need something. Just load immediate 0 or something like that. Oh, Sir Aid, you're smart. IR immediate. Well, here's the thing. We can't do that. So we have to load an IR immediate, not as our result. Our result has to be a phi to do phi stuff. And this is basically going to say load the immediate 0 into the cogent context, because so IR immediate isn't a thing. It's not, apparently. Should be a thing. We're just going to create it. Immediate. Which has a context and an immediate value. Okay, IR immediate, cogent.c. IR load has to be somewhere here. I see something happened in chat. I don't have, I'm gonna just do this right now. We're gonna call it in, I guess. I was like, what do I call it? I just had instruction, so I was like, insert. Thought it was another macro. Okay. So with IR immediate, how do we do this? To do attach otherwise block and so then block, we're gonna have to also keep track of last then block. Is this what you're saying? I put that in the wrong place. And then what we have to do is after we do this, right? then we have to say last then block is equal to whatever our current context block is. Is this what you're warning me against, Sarade? He says, make sure the blocks that you add to the fly node are the last blocks in the then and else branches, not the first blocks. I've made that mistake so many times before. Sarade says, yes, exactly. Alrighty, thank you for that warning. I very much appreciate it. That is actually huge. I'm sure will save us a lot of pain. Attach otherwise block to current function and make it active as our context block. Sure. Sure. I'm gonna have to do the same thing with if. Here, attach then block to current function and make it active as our current context block. Sarade says, yeah, code-genning ifs and loops is like trying to cross a minefield blindfolded and jumping on one leg. Sarade says, there's just so many things that can go wrong. Yeah, control flow is a bitch. They never make it easy. So to do attach join block to function and update context and set join block and set it as the active context block or whatever we said above. Attach block to current function and make it active as our context block. That's close enough. The only thing that's worse than that is defer. I know. Some people really want me to use D for some reason, and it's like D has defer. That's not okay. It's just hard to handle. It's just hard to handle. As a user, it's not bad. It's just as like trying to understand the actual code it generates is almost nigh on impossible, I would say. With all the branches and oh Jesus. It's so much. So to do phi stuff and attach join block to function and set it as the active context block. And we're gonna have to do it in the other order because the phi will go in the join block. RPWH says, what is defer? Oh boy. So defer means that any exceptions here will go to the deferred control flow. So imagine that you have something like this where you defer, I don't know, I'm not sure exactly how it works. I'll just make up a system so that it works. So like you defer on an IO exception. And then anytime there's an IO exception, Thread says that's not how defer works. How does defer work? Because I'm pretty sure I got it wrong. I'm pretty sure a defer, it has to do with going to a separate control flow based on an exception. Defer just means that code is executed at the end of the scope. What? Like a C++ destructor. I see. So defer just saves stuff for the end? That's not how I got, how I've understood, been explained defer at all. If that's all it is, I am mad at whoever explained it before. Because they explained it like defer basically is like a try catch, except for the code that you give it is it's the try, and the catch is just after the defer. Could be wrong, and I'm sure I am. So if defer, you're saying all it does is basically if I said defer x equals 0 and then said x equals 1, effectively this would mean that at the end of this control flow, x is equal to 0, right? Is that what you're saying? So the code I put here will be, it'll be yeeted at the end. Sir Aid says yes. Yeah, that's horrible. So that's how defer works. Doesn't defer have to do with exceptions? I'm pretty sure it does. I could be completely wrong. I have no clue. Is the control flow non-deterministic or something? Why couldn't you just put that logic at the end of the scope? I've implemented defer in C++ using operator overloading macros and lambdas. Sir Aid, you scare me. RPWH, basically, the use of it is to like defer free of memory, right? And you'd say like char pointer memory equals malloc 24. Stuff with memory. That's the usual use case. Sir Aid says you can search for defer in my compiler source. I'm pretty sure I use it somewhere. Yeah, something like that. File pointer fopen, defer fclose. Yeah, stuff like that. You can free memory. You could use a file pointer. Say open my file. Reading. Defer. Close. All sorts of things. RPWH. Why wouldn't you just close the file after ... stuff with memory? It's just... Exactly. You're correct. There is no reason. It'd be exactly the same. It's just that the freeing goes right next to the allocating, right? Which is malloc or something. And in doing so, you tend to not forget to free things. That's the idea. It's like C++ destructors, but manually. I really like that explanation. What does D have to do with exceptions, then? It's going to get to me now. I know I remember something. I was reading about D, and it was like, oh, there's many exceptions. I don't know. I don't know. The reason why defer is used is the same reason why RAII is a thing. No reason. No, programmers just forget it a lot. It's so easy to forget a free or an fclose. Yep. It doesn't matter, though, in the scheme of things. Honestly, there's no difference. Attach join block to function and set it as the active context block. Yep. So we have a bunch of stuff to do here, but we've made some good progress. We're going to keep going so that we can get this at least working and not just filled with errors. This will be good. There's definitely a better way to do this. I should be changing CodeGen to IR as I'm going, but I am not. Ooh, that was rough. Now back up the stack. Alrighty, that wasn't so bad. Suraid says, that's the main reason I use it. Even if you return early, the defer blocks will still get executed. That way you won't leak resources if you add another return statement. I see. That's pretty cool. That is pretty cool. It's like a little local function at exit. Okay, we've got all of those now. To do. Local variable loading is going to be overhauled in a major way. No type variable declaration. Probably forgot to get rid of a few of these. Okay. It's beginning to look a lot like we're right back where we started. It's getting better. Do a bunch of stuff with figuring out where the variable resides to figure out if it's local or global. No type variable declaration. This is going to change a little bit. Local, which equals IR stack allocate. And then we're going to have to say something like this. Yeah, so we're going to have to take this to here. There we go. And then to do, we do need to keep track of the offset so that we can know how to address this local, do we not? I don't know. We'll see. We're changing everything, so all the to-dos are leaving. And the to-do is going to be, I guess it'll be here, to-do store local stack allocation instruction probably do something like that. In locals environment, Trojan contexts locals environment. Hey. I just loop over all allocates and calculate the offsets at the end. Yeah, that's what we're going to do. I don't think there's any reason to worry about that in the front end. Yeah, that's true. So what you're saying, I see what you're saying. I see what you're saying now. Yeah, you're right. You're right. Because then when we may add stack allocations in the intermediate representation and optimization passes or spilling registers, etc., parameter references. So in doing so, we would screw up that locals offset anyway. You're right. You are correct, as usual. Best. I love having somebody who's correct all the time. I'm not used to it. It's very nice. This whole section of code is pretty non-radical, dudes. Yeah, it is. Yeah. That should just be an error. We're just going to assert iterator. Invalid or misshapen AST. Should probably make that a better something. Okay, so code in the right-hand side of a variable reassignment. If it's an access, we're going to need to get the symbol address. If error, return error. And then what is this saying? So this would be something like that. Why are you mad? because it returns void. I don't think we're even going to have add immediate. Conditional. Sure, why not? Sure, why not? We are going to need IR copy, but... Okay, so now in the local, we can say expression result. Also, we never use this expression result. The AST doesn't really need a pointer to its IR representation, but I'm sure we'll use it someday. Okay, IR store local. So we would like to store into this local is what we're saying. Something's unhappy. What's the issue? Is there one? There is one. Saying cogent store local from type void. Hello? Are you okay? Cogents? Oh, I'm an idiot. IR store local. Lol. We'll get there in the end. See, this is going to change how this works. So, yeah, this will be fine eventually. When we change symbol address. We don't need to deallocate any registers. We would like to create an IR store after generating the left-hand side. So store this value into this address. The left-hand side gives us the address. The right-hand side gives us the value. So this assignment will be generated properly. Woohoo! So expression result is set here. It's set here. We're good. Node type cast. We haven't actually done a lot of type casting. Which is interesting. Sorry, it says, yeah, I have a new node type and that stack allocation is in the environment. Haha. Nice. We'll probably make our custom IR environment or something like that. Implicit. So we need standard lib that says you don't have callic. I have a callic, I promise. Now it's saying previous definition of IR store global. Remember when we made all those pointers? This isn't going to exist, we decided. We want to return the instructions that are created by these functions. Hey, a label can only be part of a statement, blah, 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 blah. This is a horrible fix, but it does work. We should probably just put, hey, look, less errors. First time chat from Almeida lol. Hi, I just started to watch the YouTube playlist and decided to check your Twitch stream, and here you are. I'm so lucky. Awesome. I'm glad you were able to catch me live. We are winding down on the current stream, but we have just finished a huge refactor. Probably function is what it'll be called. So in CodeGen function, we're going to have to create an actual function thing. So we're going to have like IR function, pointer function equals IR function. Almeida, lol, it is so good to have you. Thank you so much for tuning in. I am a little distracted, but I'm so glad you're here. So we say function equals IR function. We're given a node function, so we're going to call this function f. Is that okay? I think that's okay, because we're not going to have to deal with it very much at all, just in this at the very bottom here. So set the return value of f. Almeida says, pleasure is mine. Aw, you're so sweet. Implicit declaration of function and register deallocate. We should no longer do explicit register allocation in CodeGen. Expected IR instruction pointer to IR store local. That's just a warning. And then it's the same thing here, but this is in, where are we? Okay. So when we're code-genning a high-level program, again, we got to get rid of some of this stuff. To-do. Whoops, what just happened? Didn't I just, okay, whatever. Generate global variables. To-do. Generate global variables in the CodeGen backend, where this actually belongs. Lol. We'll move that tomorrow. I don't have time today. So we create the main function. We don't need an epilogue. And all we have to do is say what? So we have this main function, which is part of the context. It's just the one we start on. We may end up in other functions in the future. Copy last expression into racks register for return value. Yeah. So we need the function, which is main, which is why I'm going through this. So return value needs function, so we will keep it. Almeida asks for the Discord with a command that does not exist because we have no commands. We are not officially high tech in that way. The Discord link is actually in the About section of my Twitch profile. It should be just below the stream if you are on desktop, and if you're on mobile, it should be, you have to go to my profile and go to the About tab. RPWH with the amazing link. Thank you so much, RPWH. Almeida says, got it, thank you. I'm so glad. Does that mean you're in the Dis? Hey, we got a new member. What's up, Almeida? Thanks for joining the Dis. We really appreciate that. That's the best. King Buns with the the killer gifs. I yoinked these emojis, Lamau. Are you a crustacean? No, he is. We already know this. So set the return value to the last expression if it is a thing, right? I don't think this is too complicated. Yeah. Which means, hey, it works. Now we just have a lot of undefined references to register, allocate, or deallocate. So what we're going to do is and get rid of those entirely, right? I mean, we could keep this as a non-allocating function and just have register be passed like this. I'd rather rewrite the whole backend. For most of these things, I'm pretty sure I'd just rather rewrite it. I don't want to rewrite divmod. We're gonna keep divmod. That's actually something, yeah. Shift. We're definitely not gonna have to do all this swapping, are we? Because we're gonna just register allocation will handle this. Am I correct, Sir Aid? Can I get rid of divmod and shift without worrying about having to redo a bunch of work? Or should I just get rid of the deallocates within them? And allocates, obviously, or if they exist. Because we shouldn't be doing any actual, like... This is a lot, right? Yeah, divmod, yeet, divmod, and shift, I'd say. All right, Sir Aid, we will rewrite it. Bless. We're going to keep codegen prepare call, because it scares me. Add an argument to the current function call. Interesting. We could keep this. Very interesting. So I think we're going to have to yeet this as well. It's going to be just handled completely differently because of register allocation. Yeah, that too. That's literally just going to be call. Clean up after a function call. All right, this stays because it's part of the backend. And we're going to have a whole bunch of these that now are no longer really good to go. So the idea is we're not even really going to use these anymore. We're just going to keep these right now, honestly, so that when I implement them again, I have a reference in case I get confused. So codegen, divide, and modulo, those are going to have to be their own thing. Shift, yep, we're going to have to rewrite those, I know. Codegen stack allocation, right? I know this doesn't matter, but just so I can find it in the future. Prologue, epilogue to functions. Set return value, which is probably still needed. And then codegen entry point. So really all we're going to have to do is define a high-level codegen init x86-64, right? And this is basically going to take in the context. And then to do is going to be init code based on intermediate representation in context. And then there's even going to be another to do, which is set up register allocation structures and allocate registers to each temporary within the program. Should also probably do things like, yeah. Oh, that's rough. So we're gonna have to fix up calls as well. So fix up parameter accesses, parameter references, generate spill to stack every time for now. And we're also going to have to... The issue with parameter references is a whole thing. I don't even want to get into it right now. Basically, trying to use a parameter, you need to create a copy of it. So in order to have a copy of something, you need to actually store it in memory or in a register. So that's why we're saying spill it to the stack memory every time for now. Sir Aid says you can always go back in the commit history if need be. That's what Git is for. You're right. Sir Aid says you basically need to allocate a local variable for parameters. That's a great way to put it. This converts parameters to local variables. which makes life 1000% easier. So after we fix up parameter references, we're going to have to set up register allocation structures and allocate registers. We're probably also going to have to lower... We should be fine. I think that these can be our steps for now. And then emit code based on those. So we'll have like emit function with a context IR function for it. Function to do. We'll have emit block. And then we'll have emit instruction. Function goes to instruction. Instruction. I can't type apparently. Now. Okay. Basically, now all we have to do is say block pointer. So IR block function first. Why are you mad at me for this? Incomplete definition of type struct IR function. Okay, so we just haven't included everything properly. Intermediate probably goes above. Why are you mad? Oh, because it's in CodeGen. Okay, so now for every one of these block, emit the block. Just call this block, I realized. No need for the iterator naming. And then this is just going to be a very similar thing. To do, generate block label. To do, generate function label. Something like that. And then, yeah, that should be good. So it says also getting a parameter is a separate function in LLVM. So that's somewhat telling that that maybe deserves its own instruction. So like accessing a parameter isn't just a local access. It's like a parameter access instruction, which is handled in a specific way. We should probably handle it that way as well then. That is one place where we should do the same thing as LLVM. So it says, yeah. Yeah. Handle IR instruction, IR type, blah. Okay, so now if we have like an IR immediate, we should probably handle it, but we don't yet. So that's where we're at. We've got a lot to do. It's not going too bad though. So an emit block, we want to have this be something like this. For every instruction in the block, emit the instruction. Do emit branch instruction. So this is going to be like emit instruction. Context, block, branch. I kind of like that. Okay, so we emit the branch instruction. And here we should probably like do function result return value, something like that. Pretty good. And we could just have the return value be like implicitly the last one in this list. But since the return value has nothing to do with what's in this list, the return value is always going to be its own separate instruction, because each and every temporary or each and every value in our language is going to have its own instruction. So the return value of a function will have its own instruction, even if it's a no-op and the return value is already in the proper register and nothing needs to happen. But we still need to omit it if it's there. And I don't think it should be a part of the body, because that way we can just add to the body and don't really have issues. Alrighty. We are officially getting there. And there we go. Undefined reference to register allocate. Bunch more of those. We went through and did the deallocations. Now we need to go through and say the allocations. Okay, so result needs to stay as something. So we'll just make another one of these. That didn't work. How's that? Nobody ever calls you. Okay, so all of these, by the way, now no longer need to be called from anybody except itself. So we can just do that. Isn't that nice? Okay, a little bit better. Implicit declaration of function in cogenplatforms.c. That's an interesting thing. I don't think we need it. It contains some important stuff apparently, but nothing that can't be moved around. We have cogen context create top level, a very important one. And then we have rip all this code, by the way. Goodbye. Really just cogen context stuff, so it seems like it should go in cogen C. I could be wrong. We'll see how it goes. So there's cogen context create top level, which has this function body. And then there's this. Okie doke, okie doke. This really should be a switch case. It's okay. Cogen and error. We're going to need cogen context create. Yeet. We'll leave it as one line. And we will take its definition into cogen.c. And same with this. So we can now create and free a context. Okay. Cogen branch, cogen function prologue and epilogue. Cogen branch. When did that happen? Oh, Christ. Yeah, definitely don't need to do that. We don't need to do this at all, in fact, do we? So when we cogen a function, we don't need to generate a branch past it because we're no longer generating nested functions. After name buffer undeclared. Well, there you go. We also don't need any function footer or header. Hey, we made it. We're back. The compiler runs. Hey, it fails immediately and says, hey, I don't know how to load an immediate or generate a load immediate IR instruction. It's like, I don't know, right? I'm pretty sure I wrote that, but I just called it immediate. Failed with code 5. Now we're getting to it. Now we're getting to it. That's such a rip. Lamau. But if we keep it as load immediate, it works. Hey. It's fine. You would think that it would just call to do, but it does not. Oh, I broke it. I broke it hard. We'll figure it out. Tomorrow. Tomorrow. Everything works out tomorrow. In any case, I am so glad to have gotten back into this with you, and I'm excited to just continue on this journey and learn together. I'm glad that as a viewer, you'll be able to see. Sir Aid says, I mean, it's going to be broken for a while now. Yeah. I mean, it's not generating code. It won't generate code until probably a week, right? But that's okay. Unless I have a day here where I can get in like 8 hours. But that is okay, because guess what? We're going to learn along the way. We're going to learn how intermediate representations function on a deep level on the insides, right? It's like we're going to figure out how an engine works, and we're going to, by slowly building a go-kart together. It's so much fun. Thank you everybody so much for watching. I very much appreciate it. We are going to be winding down here as we're in a good place to stop. I'm just going to start making git commits, and then I'm going to pop out of here for the day. Oh boy. So, also I don't want to save that. He. Okay, so these say modified. They should just be deleted. Sarade says, are you planning on merging the docs PR, or should I close that one too? I think we can merge that one. I don't think there's an issue. I may want to, I mean, I don't know. I think it's fine. There's nothing wrong with it. There is some things we have to fix. Right? There was the, but feel free to, we can merge it before we fix them. They're just in, like, it's already a work in progress document that isn't finished, so keeping it work in progress and not finished is not a problem with your PR, if that makes sense. But yeah, we can like merge that today. It's cool. Whatever, if you feel like it's ready and you want to merge it, let's go for it. Because it's a lot. I don't want to write 14 pages of LaTeX on register allocation, at least not today, right? I may want to someday, and then at that point I may rewrite what you wrote. Sarade says, yeah, you can merge it, I'd say. Also be right back. Hey, okay, I'll probably merge it later off stream. When I find time later today. I'm just trying to figure out how I could split this up and do commits, but I think it's all going to be one. We can't really fix this. That's how it's going to have to happen. One big change, which is kind of how we implemented it. We just went through and changed codegen.c. Alrighty, and now I can say, hey, This will be begin. We're just going to say rip and tear till it is done. Yeah. Code generation is no longer AST to code. It is now AST to IR code. Everything is broken and everything is a work in progress. Slowly, we will get back to where we were before, and quickly, we will surpass it. Can that fit? $72. Doesn't like going to 70, but I think it's fine. Okay. Almeida Law says, do you plan to do a type checker? We have already done a type checker, Almeida, entirely. It's completed. Type checking is done. As we implement new things into the language, we'll have to extend it, but type checking has already been implemented. And there's even in the developers document, if you take a look at the PDF for developers, there's even a whole section on type checking, although it's very much a stub at this point. This is it, right? But the type checker is absolutely entirely implemented and functions on the AST. So the type checker ensures a valid program before we code generate it at all. Also, these are incorrect. We can't make these static. Code gen platform. Where was that? Simple solution, remove it. Hey, right back where we were. RPWH says, so when we implementing the borrow checker? Lamau. Never. Never ever. No, but seriously, we're not. It would be funny though. Make like a lifetime managed language. That's not where we're at though. We're going for a lower level approach. We want less syntax than Rust, right? Ideally, we want even less syntax than like C, which we're doing okay so far. Like external functions aren't too insane, right? Simple math, very simple. When it comes to arrays, it's not the best. We can do better, right? It's pretty good though. Defining an array and then getting a pointer to it, etc. I don't know. I think we're doing okay. We are doing good, in fact. Anyway, that's it for today. That's all I got in me. I have to eat something before I starve to death. It's been a very long time. But all in all, I would just like to say thank you for watching. Be sure to check out all the links down below. Check out the PayPal donate button. Check out the Discord. I would love to see you in the Discord, chat with you, review your code, talk about the itself. It's a lot of fun. Also, Almeida, thank you so much for joining during this stream. We very much appreciate it. Be sure to check out the announcements channel for announcements every time I go live. And you can even ask to join this notifs group. We're working on a bot right now. That's what Meta is about. But ask me and you can join this notifs group and get notified or pinged every time I go live. With that, I will say be sure to check out the GitHub down below for all the newest source code that we worked on today. I will be pushing that right now. Big push, big push. Alrighty. So yeah, be sure to check out the GitHub for the code. Be sure to check out the YouTube if you would like to check out this VOD or any other broadcast I have ever done. That is all on the YouTube. And overall, really, I'd just like to thank you and say thank you so much for watching. I really appreciate all of you. I love you. Thank you for being there. And let's work on this compiler when we can again. I'm so excited. Intermediate representation from scratch. Hey. Anyway, bye everybody. I love you. Bye-bye. Bye.